Hello wonderful person, this is Anton, and let's discuss a few more updates about that unusual discovery, or I guess unusual announcement, in regards to several stars discovered right here in the Milky Way galaxy that seem to display signs of what's expected from a typical Dyson sphere, or basically showing us so-called technosignatures, which is something you can learn more about in a previous video you can find in the description, where I basically discuss these unusual stars, 53 stars, discovered by two separate studies that seem to possess these unusual signs. Although to be more exact, those signs were just infrared light, and specifically the excess infrared light that's sometimes expected as one of the potential signs from some kind of a megastructure covering a star. Or I guess just to rephrase this, if some kind of a super advanced alien civilization built a Dyson sphere or a Dyson swarm around a star, is going to be producing a lot of residual energy that's going to be emitted at certain infrared frequencies. And this was actually proposed decades ago by the mathematician Freeman Dyson, who thought of this concept early on, assuming the existence of Type 2 civilizations that would suddenly require so much energy that they have to capture all of this energy directly from the star. And so by looking at millions and millions of candidates in the Milky Way galaxy, and by looking at specific properties, especially infrared light, the researchers identified 53 interesting stars and 7 very interesting candidates. And it's actually these candidates that everyone is now talking about. Their names, their distance, and their overall location are listed on Wikipedia, and you can see them right here, with most of them about 500 to 900 light years away from us. And all of this is technically part of the project known as Hephaestus. You can find their website in the description below, but as the title here says, searching for extraterrestrial intelligence using indirect signatures of astroengineering. So basically this is literally a project that tries to find various technosignatures from super advanced civilizations. This is actually a project from Sweden, mostly conducted by the team from the Uppsala University. And so this was basically one of their recent studies. But naturally, even the scientists themselves, despite this being an exciting discovery, are still very cautious about the results. And so the overall conclusion in the study is that, well, even though there could be natural explanations, right now we don't actually have something that explains all 7, and additional observations are required in order to find out what's producing this extra heat. But the conclusion in the study also stresses something really important. Even though these objects resemble Dyson swarms, it would be very premature to assume that they are Dyson swarms. Mostly because a lot of this data is actually not super high in terms of quality. And so lots and lots of additional observations, and most importantly, more accurate observations, are required to confirm all of this. Because as it happened in the past, even the distances here are actually not super accurate. You can see this from Wikipedia, where for some of these stars, even the distance is up to plus minus 20 light years. But nevertheless, these unusual 7 stars now got a lot of SETI scientists super excited. Even more excited than that star we've talked about previously a few years back, sometimes referred to as the Tabby star. And so, hello wonderful person, this is Anton. Let's discuss some of the new discoveries, and I guess more negative discoveries in regards to some of these stars, and find out what's actually happening here. And so here we have a new study that just came out a few days ago, or basically like 2 weeks after the original study, that potentially explains at least 3 of these stars, basically using natural phenomena that are pretty well known and we know produce these emissions. You can find the study in the description below, but in essence the title says everything. Background contamination. And in order to conduct this, the scientists just had to do one thing. Take a look at these objects using very different frequencies and try to see if there's anything else here that was previously invisible. And so here, even though the original study used the observations from the WISE telescope using infrared light and the 2MASS using optical light, they didn't actually take a look at this using radio light. And so the infrared light was definitely detected by other telescopes, but now this team also used Very Large Array Sky Survey, VLAS, and also data from additional radio surveys to see if there's anything else here in terms of radio frequencies. But not really to look for radio transmissions or aliens trying to call us, asking what's up and so on, but to see if there's anything else here that could actually have been hidden from optical telescopes. Specifically, they focused on any radio source within approximately 10 arc seconds, because this would definitely produce contamination. And though for most of them they found nothing so far, A, B, and G candidates actually did have a radio source. You can see all three of them right here, with the G candidate having several in the same location. Okay, cool. So what does this mean, right? Well, it turns out this kind of gives us the possible answer for how these emissions were formed. Out of 7 of these stars, it looks like 3 of them are extremely unlikely to be Dyson spheres because these heat emissions are not coming from the stars themselves, but instead is maybe coming from some kind of a source similar to what you see right here, which is a very well-known phenomenon. These are actually known as hot dogs, hot dust-obscured galaxies, and they're actually very difficult to find, but they do produce very unique infrared emissions. And so technically this is actually a quasar that has a lot of dust around it, with all of this dust heated up by the black hole's emissions, making this galaxy glow in the infrared light, with some other similar galaxies such as infrared luminous galaxies producing very similar effects as well, but also usually other frequencies we can normally detect. But because there is so much dust here, most of the other light is usually blocked. And today it's actually believed that these unusual galaxies is a kind of an evolutionary process where the central black hole consumes material extremely fast, even faster than the star formation, and is technically in a process of clearing all of this dust away, eventually making this galaxy visible. And we've only known about these objects for less than 14 years. The first one was found in 2010 by actually the same survey, the WISE survey, used in this particular study, and only 1 out of 3,000 quasars is usually a hot dog. And so in essence, at least 3 of these objects discovered by this particular survey could have been contaminated by either one of these hot dogs that we never knew existed, which is quite possible by the way, or a similar galaxy that could be visible using additional observations. But basically right now this does look like a very solid explanation for at least 3 of these stars. Naturally, additional confirmation would be required by very likely using something else, like for example the James Webb Space Telescope, which can definitely tell us if this is coming from the galaxy. But because these candidates are visible in radio light, and very likely contain some kind of a jet as well, this would definitely produce enough contamination to make it appear as if it's actually coming from the star. And so essentially these 3 stars are just in front of these very unusual, very powerful objects. But this is obviously still very preliminary, and actually this paper is super short, mostly because these are very preliminary observations, and so additional radio observations and additional observations in the infrared light would definitely be required to find out if this is coming from a galaxy or from a star after all. Just to give you a comparison, here's roughly what one of these candidates looks like in infrared, and here's an observation of one of these hot dog galaxies using very similar frequencies. And so here you can tell that, yeah, they're very similar. And so if these galaxies are really in that location, that would most likely clarify 3 of these stars. Okay, what about the other 4? Well, right now there's nothing yet, definitely no additional radio observations at least, but I'm sure they're coming soon. I'm actually pretty sure a lot of scientists are currently focusing on this, basically trying to find natural explanations because, yeah, let's just be honest here, it's extremely unlikely to be a Dyson sphere. As a matter of fact, out of all technosignatures, I don't even think Dyson spheres would be the best to look for. I mean, for example, how do you even make a Dyson sphere? How would we make one right here in the solar system? Do we just basically start digging Mercury and take it apart piece by piece, trying to place it in orbit around the sun? Or do we bring asteroids from the asteroid belt? So yeah, even for a Type 2 civilization, there will be a lot of challenges in trying to figure out the logistics. And so maybe Dyson spheres are not really what we should be looking for at all. Instead, there are actually so many better alternatives, and some of them we've discussed in some of the videos in the description. I think my personal favorite one is referred to as the Clarke Belt, and it's named that after the iconic Arthur C. Clarke. It's basically a geostationary orbit belt. Here we can kind of assume that advanced civilizations, spacefaring civilizations, will probably start using geostationary orbit of their own planet. And just like around planet Earth, it's probably going to have a lot of stuff in that orbit, which would be extremely difficult to achieve naturally. And so by finding such a belt around a distant terrestrial planet, which by the way is not that difficult because they would kind of resemble a typical ring set, if we were observing a planet visible as a tiny shadow passing in front of a star, this would kind of confirm the existence of something really intriguing, making this a telltale sign that something really strange is going on here, or has been going on in the past, because these types of belts, they actually exist for a very long time, even if the civilization goes extinct. Which is technically what's going to happen to our belt. The geostationary satellites are going to be there for quite a while. Or obviously we can look for different pollutants in the atmosphere of the planet, which is another way to look for alien life. But we'll discuss a lot of these ideas in some of the future videos on the channel. Because when it comes to these 7 objects, they're definitely super exciting, but at the moment, without additional observations, we cannot make any conclusions yet. And so even though it could be Dyson spheres, it could also be some kind of a dust around the star, possibly from some kind of a planetary collision, or it could be a planetary disk, or various leftovers from the disk that also emit very similar heat signatures, or maybe even some kind of an anomaly on the star's surface that might lead us to new discoveries in stellar dynamics. So basically, at least for now, as of June of 2024, we're going to make an assumption that it's maybe not Dyson spheres, kind of, even though we obviously all want this to be a Dyson sphere. But anyway, on that note, that's kind of all I wanted to mention, and so if you want to learn more, check out all of the additional links in the description below. Hello wonderful person, this is Anton, and in this video we're going to discuss some of the recent discoveries in regards to the central black hole of the Milky Way galaxy. The black hole whose image was captured by the iconic Event Horizon telescope, and the black hole whose discovery led to the Nobel Prize just a few years ago. And in the last few months, there's actually been a few discoveries about the black hole, but today we're going to focus on one of the major discoveries. The discovery coming from this study by Wang and Zhang that in essence discovers how our black hole was most likely formed and when it was formed by focusing on certain details that were previously ignored. And so in other words, the researchers behind this study potentially discovered the origin story of the Sagittarius A star, that's of course the name for this black hole, while also to some extent answering a few questions about the formations of massive black holes, which is actually one of the major questions in modern cosmology, because scientists today are trying to understand how these giants formed billions of years ago and what exactly caused some of them to grow to enormous sizes, sometimes billions of solar masses in mass. But in order to try to start answering these questions, we obviously have to understand the central black hole of our own galaxy just a little bit better. And well, thanks to the observations from the Event Horizon telescope, we can finally start making certain conclusions. Although I guess the thing is, even though this is the closest supermassive black hole to planet Earth, it's not particularly big compared to a lot of other black holes in other galaxies. Here the mass is just over 4 million solar masses, whereas the black hole in the middle of M87 galaxy is actually closer to 6 billion solar masses. And so there's definitely a tremendous difference. Here's actually a really intriguing visualization showing us this size comparison. But because Sagittarius A star is only 26,000 light years away from us, which is relatively close when it comes to black holes, it actually allows us to see a lot of additional details that would be invisible for any other black hole out there. For example, we can observe various emissions in the X-rays, infrared and radio wavelengths, which we know this black hole produces once in a while. For example, here's one of the recent X-ray detections showing us a sudden brightening in the X-rays. And a lot of previous studies that focused on the environment around this black hole actually discovered signs of previous emissions by observing various echoes coming from the gas around the black hole that was hundreds and thousands of light years away. And as a result, today we know that every few hundred years, there seems to be at least one major eruption, possibly the result of some kind of a star approaching the black hole too close, being disrupted in the process. But this process of shredding and destruction of stars, despite being relatively powerful, does not actually contribute enough mass to the black hole itself. And that's because the majority of mass ends up being ejected from the black hole or turned into energy. And interestingly, in one of the recent studies, researchers even discovered how a lot of this energy seems to be guided by something, resulting in these unusual formations scientists now refer to as chimneys, that eventually result in various exhaust vents, where a lot of this energy is suddenly released all at once. But by observing the amount of energy released here, we can obviously calculate the amount of mass our black hole consumes every single year. And well, it's actually quite minuscule. As a matter of fact, if the black hole was consuming this much mass, it would not grow to these sizes even after 100 billion years. And so even though we found structures like the Fermi bubbles you see right here that suggest very powerful emissions, even if these emissions were happening every single year, the black hole would still not really be big enough. So it must have grown to its current size through some other means. And right now we only think there are possibly two means for black holes to grow. Either accretion of matter over time, which as I just mentioned potentially doesn't actually add enough of mass, or a massive black hole collision. And this is of course where we don't really have any evidence. As a matter of fact, this even results in what's known as the final parsec problem. It's basically an astrophysical paradox where the scientists don't actually know how two supermassive black holes could possibly collide. You can learn more about this in one of the videos in the description, but as of today, there's almost a complete lack of evidence that supermassive black holes can collide and can thus grow larger. Yet we know supermassive black holes get really big. So how exactly do they do this? And it looks like we finally have our first piece of evidence from right here in the Milky Way. And the answer seems to be collisions after all. But how exactly do we know this, and what exactly is this evidence? And turns out that all of this evidence was in these observations from the Event Horizon Telescope. And it's the evidence that shows us the spin of the black hole. Turns out Sagittarius A star is just a little bit unusual. It seems to spin really fast, but also in a little bit of a misaligned way compared to the rest of the galaxy. In other words, it doesn't actually spin on the same axis as the galactic disk itself. And this was enough evidence for the scientists behind this paper to start crunching numbers and to start producing models. With basically just one assumption, the assumption being that this misalignment was the result of a massive collision. And so following a bunch of models, they finally discovered one that seemed to fit the observations. Here this was a merger between two relatively massive black holes with a mass ratio of about 4:1. So essentially one of these black holes was about 4 times as massive. And the collision itself very likely happened with the inclination of about 145 to 180 degrees formed by the line of sight from planet Earth. And turns out that this collision basically replicates exactly what we observe here. And by having this inclination and basically by knowing how this smaller galaxy possibly orbited around the Milky Way, they now think they know exactly what happened and when. This is now believed to be the result of the Gaia Enceladus galaxy, the signs of which we've discovered around the Milky Way several years ago, that merged with the Milky Way approximately 9 billion years ago. And this seems to have been the last major merger in the Milky Way, adding a huge amount of mass to the galaxy, but also finalizing the mass of our black hole. And intriguingly, this collision very likely resulted in a star-forming period that lasted for a few 100 million years, while also changing the shape of the disk of the Milky Way, making it much thicker, and also adding a few globular clusters, such as NGC 2808 you see right here. And so it was very likely the result of this merger that basically finalized the Milky Way's black hole, suggesting that the black hole itself kind of formed 9 billion years ago. And right now this is the best explanation we have for the unusual spin of Sagittarius A star. And naturally, if the study here is correct, it also provides us with very important evidence for how massive black holes most likely grow and how they reach these massive sizes. This is actually known as the hierarchical black hole merger theory, and you can learn a little bit more about it in one of the papers in the description. And though technically this is probably the most accepted theory, up to this point there was just a complete lack of evidence. But now we have some evidence from our own black hole, which provides us with some really important answers. And it technically even tells us how frequent these collisions are around the entire universe. In other words, by learning that 9 billion years ago, Sagittarius A star was formed as a result of a merger, we can now infer a merger rate, allowing us to potentially detect one of these events sometimes in the future. And so the conclusion from this paper is that we should be seeing at least one of these events sometimes in the near future, possibly within the next 10 years. But at least for now, this is still a pretty important discovery that helps us understand the evolution of our own galaxy and naturally provides us with more details for when the massive black hole in the Milky Way actually formed, with the date being approximately 9 billion years ago. But I'm sure in the next few months we're going to discover even more details and learn so much more about Sagittarius A star and what's happening in its vicinity. Okay, it's about time we've talked about the Milky Way galaxy, and specifically some of the more recent discoveries from the last few months that once again kind of surprised everyone. And that's because in the last few years, the Gaia telescope, combined with observations from other telescopes, has been consistently rewriting all of the fundamental knowledge we have about our own galaxy. But on top of this, in the last few years, there's also been some advances in observing a lot of other frequencies, including various frequencies that actually allow us to study magnetic fields. And so in 2024 alone, there's actually been several papers discovering new things about the magnetic fields, reviewing the Milky Way galaxy in different ways we've never seen it before. And so, hello wonderful person, this is Anton. Let's discuss some of these new discoveries about the Milky Way galaxy and discuss some of this recent research with all of the studies, as always, available in the description below. And I guess here, let's begin with those discoveries in regards to various types of magnetic fields in our own galaxy. And that's because by studying polarization, we can generally start mapping the magnetic field even of various extremely distant objects. For example, we know that a lot of different gas in the galaxy is not really spherical. Most of it usually has some kind of an axis, with various particles aligning with the magnetic field, which can then be observed from planet Earth. And so as a result, we can actually study various gas clouds, or actually even stars and various galactic structures, and then see if there's any magnetic field in them. And so as all of these grains align with the magnetic field, and as they emit polarized glow, we can start making these polarization maps, which can then allow us to measure magnetic fields in the entire galaxy. And well, looks like this year, the scientists have actually started to come up with new strategies and new techniques that started to produce huge magnetic maps of the entire night skies. For example, in one of the studies from just a few months ago, researchers used a new technique that helped them measure polarization of 1500 various stars, which when combined with observations from the Gaia telescope, allowed them to map magnetic fields with extreme precision. And although this is just a pioneering technique showing us what we can actually do in the future, this is a really important first step in helping scientists demonstrate that various types of starlight polarization, combined with the data from Gaia telescope that shows us the distance, can reveal an incredible complexity when it comes to magnetic properties of various types of gas in the galaxy. And so depending on polarization, different frequencies of light will actually move through ionized gas at slightly different speeds, which allows researchers to map all of this extremely precisely. And well, one of the first discoveries from a separate paper, also in the description below, was trying to establish if the magnetic fields in the Milky Way were more or less uniform or a little bit more chaotic. And that's because based on previous assumptions, a lot of research showed that it should be more or less uniform, with the field possibly following the disk shape of the galaxy and mostly changing as the disk changes as well. But once again, by using Gaia telescope and by looking at distribution of stars and various nebula, here the researchers looked at the three-dimensional map of the magnetic field, discovering that it was not uniform at all. Here, nothing seemed to follow any kind of a galactic plane, and various magnetic fields were actually forming extremely complex shapes. But much more importantly, they also discovered that many of these fields and many of these magnetic lines were also interacting with stellar nurseries, very likely affecting the motion of gas and the motion of dust, and thus affecting star formation, which actually explains how certain nurseries seem to form. In some cases, it's actually difficult to explain if it was just gravity at work, with a much more likely explanation being very hectic and very unpredictable magnetic fields. But things get even more interesting in a separate study, because here researchers focused on something even more extreme and even more mysterious. We're talking about the structure known as eRosita bubbles. And essentially it's an unusual structure that looks like bubbles coming from the center of the galaxy, but bubbles extending thousands of light years away from the galaxy, but only visible to X-ray telescopes. And so a while back it was actually proposed that there might be two possible explanations. Either this was some kind of a major emission from the central black hole, kind of like what we usually see in a lot of other galaxies, or maybe this was actually a result of extremely vigorous star formation millions of years ago. But it was very difficult to prove which of the answers made more sense. But this is exactly what's been done in this recent study. By once again studying polarization, and by identifying several magnetized structures inside these bubbles, researchers were able to reveal something we've never seen before. Here they discovered several magnetized structures reaching heights of over 16,000 light years that seemed to be extremely organized and even formed an unusual thin filament that seemed to be 3.5 million Kelvin in temperature. but these filaments were coming from a very specific region. They were not coming from the black hole, but instead seemed to be coming from the end of the galactic bar of the Milky Way galaxy. But more specifically, this showed a direct connection to a star-forming region at the edge of the bar, which seemed to be responsible for the formation of these bubbles. In other words, this actually confirms that it was not from the black hole, it did come from a star-forming region, but not in the center of the galaxy like we previously thought, and instead at the edges of the galactic bar. And that by itself is a really important discovery. Actually, a somewhat unexpected discovery, because it tells us something about galaxies like the Milky Way we've never known before. It essentially confirms that it's not just the active galaxies that can actually produce these bubbles or produce outflows, it's also quiet galaxies like the Milky Way. But in this case, all of these outflows are just the result of star formation in an extremely specific region that was actually discovered not so long ago. And so this seems to be a phenomenon very common to various Milky Way-like galaxies, or essentially spiral galaxies that contain a galactic bar. And it's also a phenomenon that potentially explains how these galaxies grow in size and how they develop over time. Although interestingly, all of these magnetic fields are extremely well organized and seem to form these very thin filaments we've never seen before. And so it's actually these unusual long filaments of magnetization that reveal the origin of these bubbles by basically pointing at the source of the emission. And in terms of actual size, these are huge. Apparently, if we could actually see them, they would be approximately 150 times larger than the full moon. But because this is only visible with radio light, we're not going to be able to see them without specialized telescopes. But basically, this solves the mystery of eRosita bubbles. They're not from a black hole, they seem to be from a starburst region at the outskirts of the galactic bar, which is actually not that close to the center, maybe 10 to 16,000 light-years away from the central black hole. But then, on top of this, a separate study, once again somewhere right there in the description, also revealed that the galaxy itself seems to contain huge magnetic toroids. And toroids really large in size, anywhere from 6,000 to 5,000 light-years away from the center. And these toroidal magnetic fields, which are obviously still very mysterious and still not very well understood, would also very likely influence the galactic motion and various physical processes, including star formation. Although in this case, this was discovered by looking at pulsars. By studying polarized light passing close to various pulsars, scientists whose paper you can find in the description essentially created a magnetic map once again, discovering that the magnetic fields here seem to actually form a toroid that we do expect from basically any magnet, which by itself is quite impressive. But apart from magnetic discoveries, there have also been some discoveries in regards to the galactic history and specifically various galactic collisions. And so essentially scientists discovered signs of galactic collisions or some other phenomena that seem to have affected the shape of the Milky Way galaxy. And here once again most of this came from the data from the Gaia telescope. And the most important discovery here, in my opinion, is actually this. The so-called Great Wave. And so in essence, the study by Poggio and his team discovered a really bizarre wave that seems to warp the galaxy in some way and seems to represent some kind of a major collision or some kind of a major event that happened billions of years ago. Now we don't actually know exactly what this is. It could be a galactic collision or maybe something else entirely. But here once again, by looking at the data from the Gaia telescope that analyzes the motion of stars, and by comparing data from 16,000 young stars and also 3,400 Cepheid variables, they essentially discovered that many of them were oscillating as if they were moving along the wave. And not just some kind of a small wave, but a wave whose peak is approximately 650 light-years in height, with a wavelength of about 10,000 light-years. And the wave that seems to be moving away from the center of the galaxy toward the galactic outskirts. And though previously we've discussed something known as the Radcliffe wave, an unusual wave-like structure extremely close to the solar system that was discovered not so long ago, in this case we're talking about something way larger, way more extreme, and something that seems to be across the entire galaxy, which is why it's referred to as the Great Wave. Most likely a result of a galactic collision or interaction with some kind of a dwarf galaxy, such as Sagittarius dwarf. A massive galaxy that the Milky Way has interacted with for billions and billions of years. But in that sense, it makes our galaxy look like some kind of a rippling pond. as if something dropped in the center, which essentially formed waves propagating in different directions. But it's obviously not entirely certain what's happening here yet, and we'll most likely know more in the next few months. So, subscribe and stuff, because we'll talk about this again. And then on top of this, we have a separate discovery in regards to various stars around the solar system. Here scientists analyze 800,000 stars approximately 3,000 light years away from the Sun, surprisingly discovering that the vast majority of all of them were actually pretty old, over 10 billion years old on average, with some of them as old as 13 billion years old. And that's actually a little bit unusual because it suggests that the majority of stars in the galaxy were potentially formed much earlier than we thought, with the galaxy itself maturing really quickly and very likely having some kind of a super intense star formation in just the first few billions of years. And so here the discovery is that our galaxy seems to be also much older and potentially developed pretty quickly, basically in the first billion years after the Big Bang. And the fact that the Sun seems to be orbiting in this region is also kind of difficult to explain. So basically our Sun, which is 5 to 6 billion years younger than these stars, seems to be a kind of an outlier. But then another intriguing study that essentially analyzed the so-called wrinkles in the galaxy and various wrinkles that form as a result of galactic collisions, researchers once again discovered something nobody expected. Here they surprisingly found somewhat recent wrinkles potentially produced in the last 3 billion years. Or to rephrase this, they basically discovered signs of a relatively recent collision, mostly because of unusual motion of stars that implied a collision 3 billion years ago. And that's actually 5 billion years later than previous assumptions. So even though previously researchers believed that the last collision was 8 billion years ago, the research here suggests otherwise. It was potentially 3 billion years ago, with many new stars added at the same time, which is the only way we can explain such an unusual motion, with the scientists now referring to this as Virgo radial merger, something that must have happened 2.7 billion years ago, and something that very likely brought a lot of other dwarf galaxies, which eventually became various star clusters. But exactly where they are and exactly what's left of them is still unknown. At the moment we just see the motion of stars. And so essentially these were some of the main discoveries from the Milky Way galaxy in the last few months. But there was actually another discovery that I wanted to discuss, although in this case I wanted to make a separate video about this, just because it's actually quite an intriguing story. And here we're talking about a discovery of a bizarre and really massive cloud known as the Smith cloud that's actually going to be colliding with the Milky Way galaxy in the next 27 million years. Hello wonderful person, this is Anton, and today we're going to discuss yet another mystery right here in the Milky Way galaxy. The mystery of unusual formations that seem to be only visible in the X-ray light, resembling these two large bubbles, or two large shock waves, possibly coming from the center of the galaxy, or possibly coming from somewhere else, much closer to us, but essentially resembling some kind of a shock wave produced by a powerful event. And though discovered back in 2020, even today it's still not clear exactly what this is or what produced this. But these objects are usually referred to as eRosita bubbles, named after the X-ray telescope that discovered them approximately 5 years ago. And so let's discuss what the scientists have recently learned about these formations and what all of this tells us about various powerful activities in the Milky Way galaxy. But I guess first, a small clarification. These are not the same as the Fermi bubbles discovered by the Fermi telescope that are only visible in gamma rays. And Fermi bubbles appear to be much larger, over 20,000 light years in length, and seem to produce very energetic light. And though the nature of these objects is also currently unknown, once the researchers discovered the eRosita bubbles, they actually wanted to find out if these two structures were somehow related. Although in short, even today, the true answer is unknown. At the moment, these two structures seem to be kind of independent. But when looking in the X-ray spectrum, which is something that eRosita was very good at, in 2020 researchers discovered that some of the oldest X-ray structures known to us, specifically the structure known as the NPS or North Polar Spur, the structure that we've known about for at least 40 years now, and the structure that was believed to be a remnant of some kind of a supernova a few hundred light years away from us, now was believed to be connected to a few other structures They were all discovered by eRosita between 2019 and 2020. And this turned out to be a really large circular structure, basically made out of really hot gas, that was actually occupying most of the southern sky. But when combined together, all of these individual structures seem to be actually kind of connected. But here there was one mystery. Was this actually showing us something in the center of the galaxy, kind of like what you see right here, visible from the galaxy known as M82? Or was this a result of some kind of a supernova-like event that was just basically in the same location, but much closer to us? And in this case, it was actually difficult to tell which of these explanations would be correct. And that's because these observations were in 2 dimensions. So for example, if this was some kind of a massive explosion much closer to us, which was the original explanation for the North Polar Spur and this other structure known as the Lotus Petal Cloud, visible in this image, this would imply some kind of a massive explosion, potentially some kind of a massive supernova, that just ended up covering the entire night skies in this super hot gas. But if these features were much farther away, it would imply that this is something even more powerful coming from the center of the galaxy, but maybe not as big as the Fermi bubbles, but most likely not as big as the Fermi bubbles visible in yellow. Although surprisingly, it would still be much more powerful, just because the total energy in eRosita bubbles seems to be actually much higher. And so here for about 5 years now, researchers try to solve this mystery by trying to find additional clues in various images. And depending on the explanation, it would basically present the Milky Way in a very different light. Either we have these very massive explosions right in the middle of the galaxy, where the black hole becomes super active, producing huge emissions for thousands and thousands of years, or we get these really massive supernova we actually did not know existed. And to try to solve this mystery, the scientists behind the recent study decided to look at some of the dusty clouds, measuring the distance to them, and possibly seeing the signs of echoes from this powerful event. And one of the first discoveries was a series of unusual clouds up to 2000 light years away from us, whose shapes seem to match eRosita bubbles. But because these were basically the tips of the cloud, it implied that the bubbles themselves were much more distant than the clouds visible here. Here, these clouds were essentially displaying echoes or reflections that came from somewhere behind them and were now striking them, producing this extra light. And then by using additional objects, some nearby and some in front of these clouds, they were able to model this in 3 dimensions, and then tracing the center for all of this to the approximate location of the central black hole, which almost definitively proved that all of this was a result of a central black hole and not a massive supernova, thus confirming the model that you can see right here. And it also obviously proved that a lot of those previous X-ray features we've known about for a long time seem to be much farther away and all seem to be kind of connected, many of them basically being part of this bubble. Although interestingly, the southern bubble doesn't seem to have a very clearly defined border compared to the northern bubble, and nobody is certain why. Either way though, this definitively confirms that the central black hole Sagittarius A star potentially created massive emissions a few million years ago. But what's even more interesting is of course this additional study that just came out as well, that possibly even discovers the source of all of this much closer to the black hole. And this is from a separate study that was just released that used other data from the Chandra X-ray telescope in order to observe the center in more detail and in order to find out if there's actually a source of all of these X-ray explosions, if there's actually a source of all of these powerful emissions somewhere near the center. And surprisingly, they might have actually discovered the exact spot where a lot of this super hot gas seems to be created. And it's not right next to the black hole. Instead, it seems to be this unusual vent approximately 700 light years away from the central black hole, but that seems to be connected to the black hole with a very long tunnel-like formation of super hot gas. Here's one of the images of this unusual source that seems to form huge amounts of hot gas spewing from the black hole. And a lot of these X-rays produced here seem to be the result of very hot gas traveling away from the black hole inside this unusual tunnel, and then colliding with much cooler gas in this location at extremely high velocities, which then creates massive shock waves, which potentially result in this. And so these unusual formations, these strange chimneys, might be responsible for producing both eRosita and Fermi bubbles and are also responsible for many different outbursts that very likely happened in the past as well. And because these unusual events seem to be located in an almost straight line from where the black hole is, it's quite likely that they are produced by the activity of the central black hole, although obviously in this case, the X-rays we're observing coming from here very likely came from the powerful emission over 200,000 years ago. And so right now, because we know the black hole is relatively quiet, this is essentially showing us a bit of a history. But one thing that nobody knows the answer to yet is whether this is all just one event or multiple events happening one after another for possibly thousands and even millions of years. And so in other words, are these massive expulsions a result of some kind of one single gas cloud or a single outburst, or is this a bunch of smaller events that happened for a long time? Either way though, this definitively shows us that a lot of this super hot gas seems to travel inside of these galactic chimneys and then leaves through various vents, producing extremely powerful X-rays, but also creating different shock waves, which can then form bubbles very similar to eRosita and Fermi bubbles. But despite of these exciting discoveries, there are still so many unanswered questions. Hello wonderful person, this is Anton, and today we're going to be discussing a somewhat intriguing and completely unexpected discovery that essentially suggests that the vast majority of stars in various star clusters located in the Milky Way seem to have originated from just 3 main sources out there. Or basically 3 individual locations somewhere in the Milky Way galaxy that seem to be extremely active at producing most of the stars that end up in various clusters. And so let's actually discuss this in a little bit more detail, but first, a very important distinction and I guess definition of different types of star clusters out there. For example, right here you see the famous Pleiades, the Seven Sisters. Probably one of the most iconic clusters out there that's not just the nearest such cluster, but also one of the brightest and one of the best studied. Here's a rough map of this cluster showing us all of the main stars. This is approximately 150 light-years away from planet Earth, with the other famous clusters being the Hyades cluster and the one known as 47 Tucanae. All 3 of these clusters are visible to the naked eye, and all 3 are pretty well known. But the thing is, 47 Tucanae is actually very different from the other 2. As you can see, it's much brighter, much more massive, contains way more stars, and it's actually an entirely different structure. This is a globular cluster, something that we believe is billions of years old, potentially as old as the entire galaxy, and something that's usually on the outskirts of the galaxy itself. They're almost never in the galactic disk, and that's actually because their origins are still kind of mysterious, but they're believed to be leftovers from ancient galaxies. You can actually check out some of the previous videos on globular clusters exploring their mysteries in one of the videos in the description. But unlike 47 Tucanae, and unlike other globular clusters, these are open clusters. So this is Pleiades, and along with Hyades, they're essentially extremely young objects, and are most likely going to at some point fall apart. And so here we have 2 completely different clusters. The ancient globular clusters that very likely started when the Milky Way galaxy was still a baby and still growing in size, and open clusters, which are essentially also stars connected by gravity, but a lot more loosely and containing a lot less stars, usually just a few hundred, as opposed to up to 1 million in a typical globular cluster. And here, the stars are also very different. These are extremely young stars, whereas a globular cluster will have very ancient stars. But most importantly, these are usually inside the galactic plane and very often inside or very close to galactic arms. And because the majority of open clusters seem to be extremely young, it basically suggests that these objects fall apart pretty quickly. Actually, the only known open cluster that seems to be relatively old is M67, also known as the King Cobra cluster. But this one is an exception and is a bit of a mystery, and we'll actually explore this in some of the future videos. So yeah, maybe subscribe. And so anyway, with the exception of this cluster, everything else out there seems to be really young. And so the scientists believe that most of them very likely disappear because they get disrupted by various other clusters or even giant molecular clouds. But because they're so young, by basically focusing on the motion of these stars across the Milky Way, it's possible to trace back their vector velocity just to see where they might have been created. And that's essentially what the scientists behind this recent study that you can find in the description decided to do. They took a look at 272 known clusters and used the data from the Gaia telescope to try to trace back their motion. And though for many of these clusters it was a little bit difficult, for approximately 150 or about 60% of all of them, it was possible. And turns out that many of them seem to trace back their origin to a relatively similar location somewhere in the Milky Way galaxy, and specifically 3 separate locations. Here the researchers decided to name them Calendar 135, Messier 6, and Alpha Persei. So here's for example some of the members from the Messier 6 family, and as you can see quite a lot of them are actually in entirely different locations in the Milky Way galaxy, and here are some of the members from the Alpha Persei and the Calendar 135 families. And so here within about 3,500 light years away from the Sun, 155 such clusters basically came from just 3 locations in the last 60 million years. And specifically from 3 star-forming regions that seem to be extremely active and potentially contain a lot of mass in order to produce all of these clusters. And specifically here, by looking at the trajectory between about 30 and 50 million years ago, you can actually see how all of this converges into just 3 separate locations. But we obviously have no idea what exactly these families are, and they're actually just named after the main members in each of these families. In other words, the place of origin is no longer visible and potentially no longer produces stars. But each of these families does contain quite a lot of members. The biggest one contains 82 clusters, with the other 2 containing 39 and 34. With all of these families containing approximately 28,000 stars. But naturally here there are some additional questions. For example, why did all of these clusters escape their home and why they're all now in completely different locations? So basically, even though they all have common origins, why aren't they actually in the same place? And well, here the researchers worked out that they most likely got kicked out by a huge number of supernova. The supernova that then produced a kind of a bubble in the middle. And specifically up to about 200 powerful supernova would have to occur over millions of years in order to produce enough energy to dislodge and to kick out all of these stars. And so all of these powerful explosions most likely left a giant bubble in the middle of interstellar medium. And the thing is, we know these super bubbles do exist, and technically the solar system is currently inside one of them as well. And we've actually discussed this particular discovery in one of the videos right there. And so these giant bubbles that seem to be all over the Milky Way are very likely the result of these numerous supernova from the same location that in this case formed an enormous bubble at least 3,000 light years across as well. And inside of these massive bubbles, we essentially just have lower density of gas compared to everywhere else. This massive bubble is most likely directly connected to all of these star clusters within about 3,500 light years away from the Sun. And assuming that all of this is correct, all of these massive supernova would most likely leave a lot of traces in the sediment on planet Earth, which we've actually discussed in one of the recent videos you can find in the description below. And by itself, this is a really intriguing discovery. It basically once again allows us to study the history of the Milky Way galaxy, and specifically the evolution of the structure of the Milky Way, by looking at the motion of various star clusters in the last 60 million years. And since a lot of these open clusters are essentially producing brand new stars that are eventually going to go on their own merry way once the cluster falls apart, in some sense this also tells us a little bit more about the history of the solar system and how most stars very likely start their existence. And that's because most of these star clusters are eventually going to fall apart, becoming what's known as the stellar association, and even these structures will eventually fall apart, with each star acquiring their own motion. But when it comes to clusters, there are obviously a lot more mysteries. For example, globular clusters are as mysterious as they get, but even other clusters, such as the unusual superstar clusters, such as the one you see right here known as Westerlund 1, seem to be different from everything else and seem to hide their own secrets as well. Not to mention that scientists have even discovered some unusual clusters in the Andromeda galaxy that seem to be basically something in between. These actually have been referred to as the hybrid clusters, or sometimes as extended globular clusters, which have not been seen anywhere else. And some other galaxies contain more mysteries. For example, faint fuzzies. Bizarre faint formations that seem to represent diffuse clusters, but only discovered in various lenticular galaxies such as NGC 1023 you see right here. And so, yeah, there are still so many mysteries about various clusters and naturally about star formation and the evolution of galaxies. And today we're going to discuss yet another incredible discovery coming from the vicinity of the solar system, a discovery from our own galaxy, and a discovery that once again surprised everyone. And here we're talking about a discovery inside a really bizarre, enormous structure known as the local bubble, more specifically, local hot bubble. Because it seems to contain some kind of an unusual tunnel. Okay, not like an alien tunnel and not a tunnel we can travel through, but a tunnel that potentially suggests some kind of a galactic network involving interstellar gas. And so let's discuss this in a little bit more detail, but I guess let's start with the basics of what exactly this bubble is and what we know about it so far. Normally, when discussing this bubble, I love using this map by Kevin Jardine that kind of illustrates this in a very easy to understand way. Here in the middle we have our sun, but then if you travel in any direction for hundreds of light years, you're basically going to find yourself in a somewhat unusual environment containing a much lower density of matter compared to the rest of the Milky Way. Here the density of hydrogen is about 0.05 atoms per centimeter cube, which is about 10 times less than what we expect from the rest of the galaxy. So it's essentially a kind of an empty bubble, or a low density bubble formed by something extreme millions of years ago. But here it's important not to confuse this with the local interstellar cloud. This is a much smaller and denser object that technically our sun is either traveling through right now or has traveled through relatively recently. Here the density is 0.3 atoms per centimeter cube, and we've actually discussed this cloud many times before in some of the videos in the description. And while in terms of size, this is just a few light years across, whereas this bubble is approximately 1,000 light years across. And so obviously a much larger structure. And one of the ways scientists were able to discover this, and one of the reasons it's called hot bubble and not just local bubble, is actually because the atoms inside here, even though there are not a lot of them, seem to be extremely hot. On average, a typical hydrogen atom is about 1 million Kelvin, suggesting something really powerful in the past. Although a quick side note, even though they're super hot, because the density is so low, it does not mean that some kind of a spaceship would melt here right away. But it does mean that something very energetic caused these atoms to gain so much temperature. And it's quite likely that it was the result of this. For millions of years, and specifically in the last 14 million years, there must have been at least 14 to maybe even 20 different supernova, all in a relatively similar location, that basically created so much energy and had such a strong outflow that it kind of created a cavity in the middle, roughly around 1,000 light years across. And then, completely by accident, the solar system ended up right in the center. And we actually have quite a lot of evidence for this based on the observations of various sediments right here on planet Earth. In the last few years, scientists have actually discovered a lot of sediments from various individual distant supernova that happened millions of years ago, all of them suggesting powerful events that must have created this bubble and must have caused all of this hydrogen to become super hot. Intriguingly, because this is technically a bubble and it's actually expanding, right at the edges of this bubble, scientists discovered overdensities that are actively forming new stars right now. There's a video in the description talking about this more, but this basically confirms that this bubble is growing and is also forcing material on the outskirts to start forming new stars. And one of these supernova very likely ended up producing the famous pulsar known as Gemenga. It's a really unusual and a very cool object that actually forms these bizarre cometary tails as it travels across space. You can learn more about this in a video in the description. But a lot of these initial studies and a lot of these initial assumptions could not really create a perfect three-dimensional map. Basically, we knew that this unusual bubble is very likely different in shape in a vertical direction compared to the horizontal direction, but nobody knew exactly how. In other words, we knew that it was not going to be spherical and had to be most likely much narrower, just because we don't expect anything spherical in a galaxy like ours. But now, after a few years, and extremely detailed observations using an X-ray telescope, and specifically the eRosita observatory, that was able to observe the night skies for a few years, scientists might have officially mapped the bubble in a lot more detail, discovering some cool stuff in the process. Although first, it's important to understand why they were able to do this. eRosita mission is actually really far from Earth inside the L2 Lagrange point. And that means that it no longer gets any effects from the geocorona. Geocorona is a structure produced by our Sun that usually forms very diffuse X-rays produced by the interaction of the Sun with the Earth's atmosphere. And this can actually extend up to about 600,000 kilometers away from the surface, affecting X-ray observations close to planet Earth. But eRosita was much farther away, 1.5 million kilometers. And so it was actually in a perfectly X-ray quiet location where it was able to scan everything, dividing the sky into 2,000 separate sections. And so by studying each of these sections, eventually researchers realized we can actually create a three-dimensional map of this unusual local bubble. And so Michael Yoon of the Max Planck Institute, and whose study you can find in the description below, produced the map you see right here. This beautiful image shows us a lot of the locations near the Sun, but most importantly, shows us the actual shape of the local hot bubble. And yeah, it's definitely not a sphere. It actually seems to resemble what's known as a bipolar nebula, kind of similar to other nebulae we've seen before. And here you can see that the surface seems to be much bumpier, it also seems to be extremely asymmetrical, and it's a lot larger in the vertical direction compared to horizontal. And that actually makes sense. There's a lot more stuff in the disk of the galaxy, or basically in the horizontal direction, compared to the vertical location. And so it's easier for this bubble to expand vertically as opposed to horizontally. But once again, the only reason this was even visible is because of those really hot atoms of hydrogen that produce X-rays with a very specific frequency, allowing the researchers to map everything. But this temperature seems to actually have a kind of a gradient. So basically here it's not just asymmetrical in terms of shape, it's also asymmetrical in terms of temperature. And this actually confirms the supernova hypothesis. The only way this is possible is if there are lots of different supernovae going off one after another in just a few million years. This would produce the asymmetry and of course the temperature gradient, resulting in what you see right here. But as I mentioned, there was also a bit of a mystery, an unusual tunnel. A bizarre interstellar tunnel stretching towards Centaurus constellation, which seems to contain cooler interstellar medium gas flowing across the bubble. And this of course was a really unexpected discovery, but a discovery that was technically hypothesized back in the 70s. A much older study by Donald Cox and Barham Smith proposed that various massive supernovae can actually create an unusual interconnected tunnel mesh, or essentially a tunnel network, that would very likely stretch across the entire galaxy and would contain very low density gas with very low magnetic field, possibly connecting to other similar structures and possibly doing something. But exactly what and what purpose it would serve is of course a mystery. As a matter of fact, right now, it's kind of unknown what it connects to, but the scientists in the study speculate it might connect to a well-known Canis Majoris tunnel, which then connects to the Gum Nebula and another superbubble that's visible right here. The superbubble in this case would also be produced by a somewhat similar event. And the cool thing is that you can actually explore all of this by yourself in one of the incredible simulations with a link in the description that kind of helps you visualize what all of this looks like. And so the Sun is right there, it's a very tiny object in the middle, but it's surrounded by a lot of these additional features, many of them produced through various supernovae, and looks like many of them connected. And so right now this is a really cool discovery and a really cool map, but it's still unknown what exactly this network is, and even if there is a network. There seems to be a tunnel, but we don't really know yet if it's connected to anything. If it is though, and if this is actually a completely new discovery of something we never knew before, this would definitely change our perspective about the Milky Way, and also eventually help us understand its history and what role these tunnels and these networks play in its development. But we're not going to know much more about this until future observations and future discoveries, or until we find similar structures either somewhere else in the Milky Way or maybe in some other nearby galaxies. In the last few years, I've made a few videos about this somewhat unusual mystery. The mystery of disappearing or vanishing stars. And though you can find all of these videos in the description below, in a nutshell, they all discussed a very similar concept. Unusual disappearance of stars that used to be visible with older telescopes, with some examples being very extreme. Like here we have an unusual constellation of 3 stars disappearing in under an hour. And as you can imagine, naturally, these first discoveries created a bit of a mystery, or actually a really big mystery. A mystery of disappearing stars. And to date, over 1,000 such stars have been discovered, with all of them disappearing in the last few decades. In most cases, they were basically visible by some of the earlier advanced telescopes in the 50s and in the 60s, and could then be no longer visible in the telescopes today. And so, hello info person, this is Anton. Today we're going to discuss this mystery once again, and potentially discuss one of the major resolutions or one of the major solutions. And though this might not explain all of the stars, it will definitely explain at least some of these disappearing objects. Although here it's also important to note that this is not the first such explanation. Not so long ago we've discussed another star that also disappeared in 2015, but it was then explained by the James Webb, with a video in the description talking about this a little bit more. In a nutshell though, this was just an unusual type of a supernova that did produce certain emissions, we just could not see them in certain frequencies. But because over 1,000 such objects have now been discovered, this is probably one of the most intriguing mysteries in the Milky Way. So what exactly is happening here? And more specifically, how can an entire constellation disappear like this? Not surprisingly, when this was initially announced, one of the first more unusual explanations involved Dyson spheres. And so basically here, maybe we're witnessing some kind of an advanced civilization suddenly covering the stars in order to use them as a major energy source. But these explanations were pretty quickly disregarded for one important reason. By design, Dyson spheres should still be emitting certain frequencies, especially infrared light. And this infrared light should be visible with telescopes like, for example, the James Webb. But the locations of these disappearing stars were not producing infrared light either, and were actually not producing anything. And so if not Dyson spheres, maybe the explanations here were much more mundane, with some studies suggesting that maybe this was just basically a problem with the telescope, and specifically maybe this was just accumulation of dust, or some kind of an artifact inside the lens. And though this might make sense for some of these observations that were only conducted once, there were a few stars that were observed by separate telescopes and were missing in all of them. And so this was not a universal explanation either. But the majority of scientists, and I guess the main consensus here, was that maybe this was actually some kind of an unusual phenomenon involving the end of life for these stars, where they basically transition into something else without your typical supernova stage, kind of similar to some of the most massive stars that sometimes just collapse directly into a black hole. And in this particular case, if a large star suddenly turns into a black hole, it can potentially leave nothing behind. And though this has never been directly observed, mostly because it's obviously very difficult to see, it kind of has been predicted before. And so could all of these stars just be gone because they all became black holes? And here we might have our first really intriguing evidence. The answer could potentially be yes. For the first time ever, we actually have direct evidence of at least one such black hole very likely formed as a result of a direct collapse without any supernova remnants and without any disturbance in the entire star system, basically proving to us that black holes do indeed collapse from really massive stars just like that, without any fanfare, without any announcements. And in order to understand what's happening here, we have to look at a star system discovered 2 years ago, an unusual system known as VFTS 243. This is in the Large Magellanic Cloud in a famous Tarantula Nebula. Now this nebula is really important because this is actually where we find some of the most massive stars ever seen. As a matter of fact, the record holder, the star that could be about 300 solar masses, is also in this nebula. That star is known as R136A1, and you can learn more about this in some of the videos in the description. And well, one of the main reasons this particular star system is so exciting is because by looking at this star, the researchers discovered something really intriguing. Here, by using something similar to radial velocity method, where we usually find different planets, and by essentially looking at the star and observing slight red shifts and blue shifts of the star, the scientists discovered that something is orbiting here as well. But not a tiny planet, because the red shifts and the blue shifts were massive. Instead, this object was quite obviously orbited by some kind of an invisible, ultra-dense object. But because no additional emissions were produced, the only thing that would make sense here is a slightly distant black hole, and a really massive black hole. The black hole here is about 10 solar masses, whereas the star itself is approximately 25 solar masses, with the star just over 7 million years old. And though obviously we don't see the black hole, we see the star. And the orbital motion, or the redshifts and blueshifts, definitely tell us it has a really massive partner. But so far none of this is unusual. These binary systems exist everywhere, and this is kind of expected to be produced as the stars get older. As a matter of fact, even this star has a chance of becoming a black hole because it's relatively massive. And so this will probably eventually become a black hole binary. But there is something very strange about the star system based on the orbit. Unlike a lot of previous observations from other star systems, here it's quite apparent that this black hole seems to orbit around the star in a very circular manner. And because the star system is only a few million years old, this actually creates a bit of a problem for how exactly this black hole formed. Now, in a typical scenario, we obviously expect a star to go supernova and to eventually leave behind a remnant, such as a black hole or a neutron star. And in pretty much most of these cases, we also usually find a lot of gas and a supernova remnant, which can last for thousands and thousands of years. We've actually recently discussed some of the most famous ones in the Milky Way galaxy, with several exciting discoveries you can learn more about in one of the videos in the description. But in this case, first of all, there was obviously no supernova remnant, but more intriguingly, the orbit was almost perfectly circular. And that's very unusual because in most cases, when a star goes supernova, it's never really perfect and it's usually extremely chaotic. As the star explodes and as it forms this huge cloud expanding in every direction, it's pretty much always a little bit one-sided. It's never really symmetrical. And as a result of this asymmetry, it usually produces what the scientists refer to as a natal kick. Or basically the neutron star or the black hole produced by the supernova acquires a vector of velocity in a certain direction, which by itself is usually really random and can even be really high. Here's actually one of the more extreme examples. These are known as cannonball pulsars, or essentially neutron stars that received such a huge natal kick that they actually started to move through their supernova remnant at very high velocities, almost resembling some kind of a comet. And in some cases they actually move at really high velocities, up to several thousand kilometers per second. But that's of course the extreme case. In a typical case, they still get some kind of a kick, but this just usually results in their orbit becoming a lot more eccentric and a lot more extreme. And this is basically how we usually get so many X-ray binaries, or basically various black holes consuming a lot of mass from their partner star and releasing all of this as powerful energy visible in the X-rays. And so a typical supernova is usually going to result in at least some kind of a natal kick. Yet strangely enough, in this particular star system, even though it's kind of young, it seems to show no signs of such a kick or no signs of supernova remnant either. And though at first this was a bit of a speculation, it has now been officially confirmed by several studies and presents a kind of a really intriguing mystery, or potentially a major solution. Because the main explanation now suggests that this is actually a result of a direct collapse without a supernova and without any other transitional stages. And so here what we seem to have is a relatively massive star basically instantly becoming a black hole, disappearing from the night skies without any announcements. With the implication from the study being that this is exactly what happened in these vanishing stars discovered back in 2019. And maybe black hole formation is a lot more diverse and more mysterious than we ever believed. Now obviously why this happens nobody knows. I mean, it could be some kind of a failed supernova, or maybe this is a mechanism that we've never really explored before, but because black hole collapse was previously proposed by other studies, having this evidence is really important. Although obviously here, to make this official, we would obviously have to find more similar objects and more evidence that this is widespread. And because these black holes would also not really emit a lot of light, remaining rogue black holes traveling across the Milky Way galaxy, at the moment there is unfortunately no way for us to directly detect these and to confirm if this is what happened to those stars. But by finding similar binaries to this one, with perfect orbits and without signs of supernova, we might actually have more evidence that this is exactly what happened here. And so yeah, unfortunately, not aliens, not unusual physics or some unexplained phenomena, but possibly just more black holes, which suggests that black holes might actually even be more common than we ever thought. In the last few years, various observations around the Milky Way galaxy revealed something somewhat unexpected. A collection of different clouds, usually molecular clouds, that were surprisingly massive and were somehow staying together without falling apart. And one of these clouds is extremely famous. And it's something I wanted to begin with, just so that it would help you understand what we're actually discussing. And you can see this hydrogen gas cloud right here. Today this is known as the Smith's Cloud, because it was officially discovered back in 1963 by Gail Bigger Smith, an astronomy student in Netherlands who discovered it completely by accident. And well, back then it was not clear exactly what this was, but just over a decade ago, additional studies on its trajectory determined that it was actually moving around the Milky Way and seemed to have left a certain region approximately 70 million years ago, but more importantly, was going to collide with a different region in approximately 27 million years from now. And when this happens, it's actually believed that it's going to produce an enormous starburst region, potentially creating hundreds if not thousands of new stars, with many of these stars very likely going supernova. And that's because this cloud seems to contain approximately 1 million solar masses in terms of gas, enough to initiate a major star formation. And that's because this object seems to be really large, over 11,000 light-years in length and almost 3,000 light-years in thickness. So it's actually the size of a typical dwarf galaxy. And because it's also really massive, and also because it seems to be in one single piece, it was actually believed to be possibly either a remnant of an ancient dwarf galaxy, but just a galaxy that no longer contains any stars, or maybe even what's known as a dark galaxy, or literally just dark matter containing a lot of gas where the gas has not actually formed any stars yet. We've actually discussed this somewhat hypothetical concept in one of the videos in the description, but this was basically one of the primary candidates for this idea of dark galaxies. And as a result, a lot of scientists were always kind of curious to find out what this actually was, or what's going to happen to our galaxy when it collides with it in 27 million years. And in some of the most recent studies from just a few days ago, researchers tried to do just that. They actually tried to see if they could discover additional elements that are potentially already colliding with the Milky Way, but unfortunately it was impossible to see anything because the Milky Way galaxy was actually hiding this region from view. And instead, by accident, they discovered something else about the Milky Way. They actually discovered that certain layers in the Milky Way seem to be extremely different in terms of thickness. In the inner region, most of the gas seems to be about 330 light-years across, but farther away on the outskirts, it seems to be double the size. And so the Milky Way galaxy potentially has an unusual, somewhat flattened shape near the center when it comes to gas, and is a little bit thicker on the outskirts. But it's not entirely clear why this is so. But despite this accidental discovery, not much new stuff was discovered about the Smith's Cloud, except that previous studies potentially discovered that this is not a galaxy. This seems to be what's known as HVC, High Velocity Cloud, or essentially a chunk of matter that gets stretched by the gravity from the galaxy, which essentially produces this cometary appearance. But much more importantly, researchers were able to discover its overall velocity, which seems to be close to 300 km per second, and discover its composition. It seems to have extremely similar composition to what we actually find on the outskirts of the Milky Way. For example, here they discovered quite a lot of sulfur, which would be impossible if this was an early dwarf galaxy, or if this was some kind of a dark galaxy. And so instead, this indeed seems to be a part of the Milky Way that somehow became ejected and turned into a really massive object. And by itself, this actually provided some explanations for why our galaxy sometimes seems to have unusual and anomalous chemical compositions that potentially came from somewhere else, so it could have been delivered in this way. But the question is, how did this form and where did it come from? With the other obvious mystery being, how is it that it's actually not falling apart while moving at these really high velocities? So basically here we had an unusually stable cloud moving at 300 km per second and basically not really falling apart, maintaining its overall shape. As a side note though, these types of objects and these types of collisions that then produce a tremendous amount of supernova all at once, right now are the best explanation for the existence of various regions in a galaxy, such as the local bubble. This huge bubble over 1,000 light-years across, where the solar system is located, is essentially this empty space formed by tremendous amount of supernova that all happen around the same time. And because this bubble also contains huge chunks of hydrogen clouds in various places, a very similar collision with a very similar cloud several million years ago potentially explains what happened here as well. And so these types of clouds might actually represent an extremely common phenomenon that basically resupplies our galaxy and recycles a lot of material. But once again, where do they actually come from? And what caused it to leave the galaxy, traveling in such a weird way? It must have come from somewhere on the outskirts, but the mechanism of ejection was impossible to explain. And so maybe even before this, it actually came from somewhere else. And here we do have one potential explanation that now might even have evidence. And it's a phenomenon researchers sometimes refer to as the galactic fountain. And here's one of the more famous examples of how this could work. This is the nearby Centaurus A. And so for many years it was believed that maybe this is how these clouds form. They are basically ejected from the center of the galaxy, with some of these hydrogen clouds making these really thick formations that travel for millions of years, eventually returning to the outskirts of the galaxy. But previously, the only possible evidence we had was the famous Fermi bubbles. These huge bubbles visible in gamma rays that suggested some kind of a major emission from the center of the galaxy. Now though, researchers discovered something much more concrete. In one of the recent presentations, based on the observations from the Green Bank Observatory, Felix Lockman accidentally discovered over 250 neutral clouds being blasted from the center of the galaxy and forming these really thick, really massive, and very stable shapes, which most likely represents a previously undiscovered population of clouds that seems to carry matter away from the nucleus of the Milky Way and then recycles it across the galaxy. And so this potentially suggests that the Smith cloud and a lot of similar clouds might have been formed in a very similar way. This was a result of some kind of a major emission from the center of the galaxy that ended up ripping apart a huge area near the center, throwing everything away, with many of these clouds moving at hundreds of kilometers per second. Actually, some of them are moving so fast they might even escape the galaxy. And this is right now the highest outflow velocity of any gas cloud in the Milky Way. And quite a lot of them contain hydrogen clouds, a lot of molecules, a lot of dense gas, and of course elements like sulfur. But once again, it's unclear how they're able to maintain their stability and why they're not falling apart. Now, the only explanation we have right now is the mysterious dark matter, but at this point, nobody knows. Importantly though, this is a very similar phenomenon we observe in other galaxies, and also seems to be extremely similar to the same phenomenon that formed the Fermi bubbles. So here it's expected to be either the emissions from the central black hole, or possibly massive star formation that released all of this gas all at once. Either way, these clouds have to contain enough mass and enough gravity to prevent them from falling apart, and eventually a lot of these clouds are going to come back and fall back into our galaxy in an extremely similar way to the Smith cloud, which is also most likely going to cause a massive star formation in the region of that collision. And so for all we know, it's quite possible that this is a new phenomenon we never knew existed, and it basically involves some kind of a fountain-like motion around the galaxy, where a lot of gas from the center gets ejected, re-enters the galaxy on the outskirts, recycles a lot of material, creates new stars, and over time reshapes the galaxy dramatically. And because here we're talking about over 200 different clouds, with all of them possessing a lot of mass, this is definitely a very influential phenomenon. We just have no idea what actually caused this, or what exact effects this has on a typical galaxy like the Milky Way. But this also suggests that there might be thousands of these clouds around the Milky Way, currently flying around, recycling various elements, and initiating star formation in various regions, with many of these clouds still being on the outskirts and possibly much farther away from the disk of the galaxy. And if this is confirmed, this would be a really intriguing new phenomenon we've never known about. First of all, how do these clouds maintain their shape and what prevents them from falling apart? Second of all, what exactly produces all of this? Is it black holes or is it star formation? And I guess third of all, what exact effects does this have on our own galaxy? And well, right now there are no answers yet, but I'm sure in the next few years we might have some. And so once we do, we'll come back and talk more about this in some of the future videos. And this time we're going to discuss something that we've discussed many times before, but it looks like, there might have been a mistake. Not made by me, but made by a lot of scientists working with incomplete data. And so basically here, the title of this video is probably going to be something like, looks like we were wrong about the Milky Way and the Andromeda collision. because that's basically what the video is about. The collision between our galaxy and the Andromeda that has been discussed in many previous videos before, that many scientists believed would eventually happen, currently, based on some of the most recent observations, may not be so certain after all. And so in this video we're going to discuss some of these new discoveries, what this essentially means for our galaxy, and of course what's being proposed now. But I guess first, as always, let's start with a bit of a history. And mostly to help you understand why we always thought that these two galaxies are actually on a collision course. And all of this technically starts over 100 years ago. The American astronomer by the name Vastos Slipher was trying to examine Andromeda galaxy sometimes around 1912. And back then astronomers didn't even know galaxies actually existed. For approximately 2 more decades, most astronomers assumed that these galaxies were basically unusual nebula inside our own galaxy. So back then, astronomers thought that the universe was much smaller, sort of the size of a typical galaxy. And you can learn about this concept of discovering the entire universe in one of the previous videos in the description. And so while Vastos Slipher was looking at Andromeda, he noticed something very unusual. This peculiar nebula was actually blue shifted, suggesting that it was basically moving toward planet Earth at a relatively high velocity of approximately 110 km per second or 65 miles per second. And not so long afterwards, basically when we realized that these are galaxies, researchers realized that there's actually a very high chance that this galaxy at some point will collide with the Milky Way. But up until early 2000s, all of this was super hypothetical and extremely uncertain. But once we got the Hubble telescope, and once the researchers started to observe some of the stars inside this galaxy, they were able to collect various types of data in regards to the positions of stars inside this galaxy, in relation to various background galaxies, and everything else around the Andromeda. And by collecting a lot of data for approximately 1 decade, so basically between 2002 and approximately 2010, sometimes around 2012, several papers came out suggesting that our two galaxies, despite relatively large distances, seem to be on a collision course. This was discovered by analyzing thousands of different stars and the relative motion compared to galaxies behind them. But even though in this case the velocity toward us was pretty accurate, so approximately 110 km per second, it was still somewhat difficult to establish the lateral or sideways velocity. So basically here we knew that the stars are headed toward us, but would they also headed left or right? Or would they just head it directly for us? So that's obviously not something we could establish yet. On top of this was way before we discovered a lot of satellites around the Milky Way and the Andromeda, and so back then the knowledge of the so-called local group was actually kind of minimal. Here the local group basically refers to all of the local galaxies, including all of the satellite galaxies, of which we've actually discovered so many in just the last decade. As a matter of fact, some of the biggest discoveries and some of the most unusual galaxies were only discovered in the last 10 years. For example, galaxies like Antlia 2, which was not even visible until recently, was literally hiding in plain sight, with 2 more galaxies around the Milky Way discovered in 2024 alone. And because of various discoveries in the last few years, modern theories suggest that our galaxy potentially has several hundred different satellites, as opposed to just having like 5 or 6 back when these calculations were initially conducted. And this particular fact is going to be super important in just a moment. Either way though, following the initial assumption that these two galaxies are colliding, quite a lot of simulations, including this one, basically try to recreate what all of this might look like. And back then, the result of this collision started to be referred to as Milkdromeda, something that would possibly happen in approximately 5 billion years from now, with several studies even trying to predict what's actually going to happen to the solar system and planet Earth. Well, by then planet Earth would actually be super hot, so obviously there would be no life here, but the sun would still be around. And here the simulation suggested that either the sun gets kicked out from the galaxy, or it potentially approaches the inner galaxy, possibly even super close to the central black hole, which might even shred it apart. But obviously all of these were just assumptions, and as you're going to discover now, were probably completely incorrect. But galactic collisions in Andromeda and the Milky Way have obviously happened many times. As a matter of fact, in one of the most recent studies from 2023, researchers even found evidence for what seems to be a major galactic collision in the Andromeda that possibly happened just 1 billion years ago. Moreover, we've also discovered signs of recent collisions in the Milky Way, and we know that galaxies like Sagittarius Dwarf Spherical Galaxy are currently colliding with the Milky Way as well. At the moment, not much remains of this galaxy, but it's still kind of there and it's still kind of visible. Alright, well, let's get to the point. So what about the Andromeda and the Milky Way? Well, now we get this recent study based on some of the most advanced observations, and it essentially suggests that the Andromeda-Milky Way collision may not actually happen at all, or if it does happen, it's going to be much later. And Till Sawala and his team came to this conclusion for one simple reason. The most recent and extremely accurate observations from the Gaia telescope that allows us to measure the motion of the stars super accurately, mixed with new simulations that didn't just include two galaxies in it, like the one that you see right here, but also included other masses around these galaxies, including some of the largest satellites. And so once these new simulations were ran, researchers realized that there's just way too much uncertainty right now when it comes to motions of some of these stars used previously, but also other galaxies, such as satellite galaxies, that definitely play a super important gravitational role when it comes to this collision. And so here, depending on the situation, these galactic collisions end up in a lot of different scenarios, with many of them resulting in no collision whatsoever. But approximately 50% do result in a collision, although in this case, maybe in about 10 billion years. Not 4.5 or 5 billion years as we previously believed. And yeah, by then, the solar system is definitely going to transition into something entirely different. And so in essence, in this particular study, the important addition was the so-called confounding factor, involving various gravitational effects of a lot of smaller galaxies that we definitely know exist everywhere around us. As I mentioned previously, there's possibly up to 500 tiny galaxies around the Milky Way, as suggested in one of the recent studies you can learn about in one of the links in the description. And each of these hundreds of galaxies provides an individual pool, slightly shifting the Andromeda and the Milky Way as they're headed toward each other. And because the current distance between galaxies is actually pretty far, 2.5 million light years away from each other, it essentially means that there's a high chance these galaxies are going to miss. So just to give you a visual example, right there on the right, that's the Andromeda, and on the left, that's the Milky Way. So they're still pretty far from each other, and are technically moving really slow. And since Andromeda is also highly influenced by the Triangulum galaxy, the M83 you see right there, this makes this trajectory prediction super challenging. And even if it does happen, it's definitely not going to resemble what you see right here. It's going to be way more complicated and involve a lot more galaxies. But at some point in the next few years, we might actually have our final answer. And that's because Gaia telescope is going to be releasing its new data, which will hopefully be enough to establish the exact trajectory of not just these galaxies, but also satellites around us. And though at some point, billions of years from now, we do expect all of these galaxies to basically become just one large galaxy, based on this new study, all of this might take much longer, possibly over 100 billion years, for everything to finally collide. But when it comes to Earth, and specifically life on Earth, we're definitely not going to witness any of this. Within the next 500 million years to possibly 1 billion years, the sun is going to become hot enough to basically evaporate oceans, potentially stopping the plate tectonics, which will very likely end most complex life on planet Earth. There might be some bacteria for like a billion years or so, but by the time these galaxies come even close to each other, all life will be extinct. And Earth, if it's still around and somehow survives the red giant stage of our sun, will eventually have its night skies transformed completely. And at some point, possibly in the next 100 billion years, it's going to resemble something like this. That's essentially when all of the galaxies combine into a large elliptical galaxy, which may or may not transform afterwards. But at least for now, looks like maybe Andromeda and the Milky Way might still orbit each other and potentially not collide for a much longer period of time than we initially thought. And so quite a lot of videos I made previously, I guess like 5, 6, 7 years ago, now essentially become, completely wrong. But that's the beauty of science. Sometimes you get new facts and you have to revise everything. And right now the observations and the simulations in this paper seem to be the most accurate. And today we're going to discuss some of the most recent discoveries about the central black hole right here in the Milky Way galaxy, and the discoveries from the central galactic region where the black hole, also known as Sagittarius A star, is located. And that's because in the last few months there's been quite a few different discoveries, with the most recent discovery from the James Webb Space Telescope actually seeing something for the first time ever and potentially explaining the mystery of black hole flares. And so let's talk about this in a little bit more detail, starting with something we've actually discussed previously, but somewhat briefly, but basically a discovery coming from the center of the galaxy generated by the black hole itself. And this was actually a really bizarre discovery of massive clouds of gas that were all actually blasted away from the center of the Milky Way and moving really fast in two separate directions, with many of these gas clouds representing material from the central region and potentially created by the black hole emissions or maybe by various types of starburst activity that sometimes happen in this region as well. Either way though, it was actually bizarre to find so many of these really massive, very large clouds moving extremely fast away from the galaxy, in many cases at over 400 km per second. And some of these gas clouds were moving faster than any other cloud we've seen anywhere. But intriguingly enough, they didn't just contain hydrogen, they also seem to contain more complex molecules and somewhat dense cold gas that we actually often associate with things like, for example, planets, which suggested some kind of an extremely violent ejection from the center of the Milky Way, but not violent enough and not powerful enough to destroy these molecules or to destroy the density of these clouds, which suggests that back in the days, possibly millions of years ago, there was a lot of violent activity in the center of the Milky Way galaxy, very likely coming from Sagittarius A star. And we can actually combine these observations with various observations in radiolite, which is actually something that was done in the study you can find in the description, which will suddenly reveal additional details in regards to magnetic fields in this region as well. And so in the last few months, researchers have also analyzed the magnetic field in order to discover potential relationship between various types of dust and various types of gas in this region, and the magnetic fields that are probably guiding this gas, which can actually then result in star formation or even in the feeding of the black hole. So basically, as we know from some of the previous discoveries from other galaxies, the magnetic fields will actually often feed the black hole by constantly supplying a lot of gas and a lot of dust, which then falls into the central region and essentially causes the black holes to awaken and to start producing powerful emissions. And so here, trying to find the exact relationship, and especially how this works in the Milky Way, one day will help us understand the evolution of the galaxy, and thus the evolution of various stars, maybe even answering the questions of the origins of life. But because the central galactic region, or the central molecular zone, actually contains 60 million solar masses of dust, trying to analyze all of this and trying to see how all of this works is obviously a little bit complicated. But a few months back, researchers were able to create this map, showing us a lot of hot gas in pink, cool dust in blue, and a lot of radio-emitting filaments in yellow. And also discovering that the magnetic fields, and especially their direction, seems to actually vary across the clouds, and seems to be in different directions, depending on where they are. And so exactly how this works right now is a bit of a mystery. This is not as simple as some kind of a magnetic field around planet Earth or around a typical star. But there were also some additional observations using the Chandra X-ray telescope that allowed researchers to also discover a lot of super hot gas that might be produced through different means as well. And so here, by observing this in the X-rays, scientists discovered several unusual structures containing very hot gas that seem to contain certain regions where this gas was violently escaping from something else, producing really bizarre, very straight structures with gas moving super fast. And here, this actually seems to be part of a much larger structure that's almost tunnel-like in shape, or is possibly shaped like some kind of a cylinder, extending across for several hundred light years, with Sagittarius A black hole in the center. And this very bizarre structure seems to funnel a lot of gas, a lot of really hot gas, possibly away from the black hole, through the mechanism that we still don't understand. But it looks like in certain regions of this bizarre tunnel, there are certain locations that the researchers refer to as chimneys that seem to vent a lot of this hot gas all at once, with the one that you see right here being approximately 700 light years away from the central black hole. And though it's not entirely clear where this gas is coming from, it's believed to be the result of material that fell into the black hole that eventually produced enough energy to eject a lot of gas, forcing all of this gas in this tunnel, which then escaped through this chimney. And this seems to be correlated with the X-ray flares that scientists believe happen around Sagittarius A star every 200 years or so. During this time, enormous amount of emissions produce huge amounts of X-ray radiation, which then very often reflects from the plasma around the black hole and then becomes visible as these very bright, hot echoes. And so a lot of these X-ray flares also seem to drive a lot of this gas upwards, with some of this gas escaping through the chimneys. But exactly what produced these flares and exactly how they work was always a bit of a mystery. But this mystery might sort of be resolved now through the observations from the James Webb, and specifically the most recent observations and the most recent study, in this case by Sebastiano von Fellenberg, that was just released in January of 2025. This was the first ever observations of Sagittarius A star in mid-infrared light. Or to be more exact, it was the first detection of a flare in the mid-infrared light that was then followed by radio emissions that allowed scientists to explain what's happening. This actually happened back in April of 2024, but it did take some time to explain and to analyze. And so here, by using MIRI on top of the James Webb Space Telescope, researchers observed a very unusual flare coming from Sagittarius A star that was actually evolving in just a matter of hours. Now, because Sagittarius A star is considered to be a relatively quiet black hole, at least nowadays, seeing any flare here is usually kind of exciting. But because, as I mentioned, we don't really understand what causes these flares, and why some of these flares become so much brighter than other flares, that's what the researchers wanted to understand by conducting these additional observations in other wavelengths. What you're seeing here, for example, is actually the X-ray emissions detected from a flare in 2015. But the modeling and the simulations explained all of this as a result of magnetic field snapping, or specifically the interaction between magnetic field lines and the accretion disk that causes certain field lines get close enough together, making them join and releasing huge amounts of energy that can then be seen as synchrotron emissions, basically charged particles suddenly accelerating and producing certain wavelengths. And so the radiation emitted through the snapping of these magnetic lines is what we usually observe as a kind of a flare. These are usually formed by magnetic lines closest to the black hole itself and the ones that are usually most entangled. And a very similar process is also believed to be responsible for the production of the jet. But here the magnetic lines and the field itself is much stronger. And so for Sagittarius A star, because the black hole is much more quiet and doesn't contain as much material in the accretion disk, previous models established that we're only going to be seeing flares, and very likely flares, in specific wavelengths. But it was actually the observations in the mid-infrared that were kind of missing in order to provide needed evidence. And because now, for the first time ever, researchers captured a mid-infrared flare, it became possible to finally figure out what's happening here. Here, this flare lasted for approximately 40 minutes and was surprisingly then followed by another flare visible in radio light. Nothing was actually visible in the X-rays or gamma rays, and that's very likely because the electrons here were not accelerating fast enough and were only producing emissions in the infrared and in radio light. But 10 minutes after the infrared emissions, radio emissions were detected as well, which basically implied that it was probably coming from the same event, and the only explanation that kind of made sense was the one involving electrons that were accelerated by the magnetic fields, and specifically through the magnetic line reconnection, and were then cooling down by releasing all of these flares visible in the infrared. Here this even allowed us to measure the magnetic field, which seems to be approximately 40 to 70 Gauss, which is roughly around 100 times stronger than the magnetic field of planet Earth, but surprisingly is somewhat similar to what we actually observe around the Sun. And so in some sense, this flare was actually kind of similar to a typical coronal mass ejection that's actually caused by a very similar magnetic line reconnection. And so around the Sun, something very similar happens all the time, and is also the result of magnetic fields and magnetic lines reconnecting once in a while. And so here we basically have an official confirmation that a lot of flares around black holes seem to form through magnetic line reconnection. And depending on the strength of the reconnection and the strength of electrons released, it will basically result in different energies and flares observable in different wavelengths. And so lots of different pretty exciting discoveries coming from the center of the galaxy and from the central black hole, but obviously also still a lot of mysteries and still a lot of unanswered questions. And looks like once again we have some kind of a bizarre, unexplained discovery coming from somewhere out there in our galaxy. A new, unusual object we've never seen before, and an object that currently is basically impossible to explain. And you're kind of seeing it right here. A bizarre, icy object somewhere in our galaxy that doesn't resemble anything we've seen before, and nobody can currently explain what we're even looking at. And so let's discuss this discovery from the Japanese astronomers in more detail, starting with how this was found and what the scientists have recently uncovered by doing a follow-up study and by conducting additional observations. You're probably aware that US and Europe are not the only countries launching various space satellites, and Japan has actually been doing a pretty good job at this as well. And back in 2006, they launched Akari. This was a Japanese space telescope, sort of I guess similar to a kind of a baby James Webb Space Telescope, that for approximately 5 years scanned the night skies in infrared frequencies. And during its operation, it basically observed the entire night skies until the unfortunate electrical failure in 2011. And in 2023, or approximately a year and a half from when I'm making this video, it re-entered atmosphere and crashed into our planet. This picture from Joseph Remy shows us the approximate position. And during its operation, it did actually make a few intriguing discoveries. For example, first ever infrared detections of a supernova in Small Magellanic Cloud, various molecular clouds around active galactic nuclei and large black holes, lots of different star-forming regions in our galaxy and outside of the galaxy, but also a few objects that were kind of unusual and somewhat difficult to understand. And two of these objects basically kind of looked like this. This was from our own galaxy. And even though these objects appeared to be very close to each other, they were actually separated by a relatively large distance. In other words, they appear to be kind of unrelated to one another. And here we're talking about distances in tens of thousands of light years away from planet Earth, basically almost on the other side of the galaxy. But unfortunately, this telescope was not powerful enough to tell us exactly what this is and to separate wavelengths of light in order to provide details of composition. And so for basically almost 2 decades now, a lot of these objects remain kind of mysterious and practically forgotten. But in this recent study, the Niigata University researchers, whose names you see right here, decided to finally conduct a follow-up using modern telescopes such as ALMA. And this is where essentially the mystery kind of starts, because it looked like nothing we've seen before. It appeared to be either some kind of a really dense gas cloud, maybe some kind of a young star, or maybe something else entirely, but it also appeared to be essentially some kind of an icy object with something relatively bright and something relatively hot in the center. And so right now they're just called peculiar embedded icy objects. Peyo, I guess. But the more surprising fact is that there seem to be 2 of them in a very similar location in the night skies, but really far away from each other. So this is not just some kind of a single phenomenon. And the fact that they don't look like anything we've seen before is really why this is probably one of the most exciting discoveries in the last few years. But we obviously have some details based on ALMA observations. For example, first, these 2 objects seem to resemble each other, and they're also very small compared to a typical gas cloud. So these are not nebula, these are not molecular clouds, these are not your typical clouds that usually result in new stars. As a matter of fact, in terms of size, they seem to be about the same size as a typical star system, or maybe just a little bit larger. But their composition is very strange. It's basically mostly ice. Here scientists discovered a lot of carbon monoxide, a lot of silicon monoxide, and yeah, ice everywhere. Which is pretty bizarre because we would expect something like, for example, maybe more hydrogen, or maybe even water, somewhere in these observations. Instead, we seem to see a lot of silicon, and actually way more than carbon, which is very often associated with some kind of a really powerful cosmic explosion. For example, some kind of a young star producing all of this material, emitting it into outer space. But here this would not really make sense because these are really small objects, and a typical star that would produce this, such as a Wolf-Rayet star, is way larger. On top of this, these objects are quite isolated, they don't seem to have any neighbors or other clouds near them, which means that these are unlikely to be new stars, they're also unlikely to be just parts of some kind of a larger cloud, and unlikely to be stars escaping a typical star nursery. And so here we have something relatively small, very isolated, enriched in a lot of different ices whose origin is a little bit questionable, and more importantly, combining all of these features and observations together, we get an object we've never seen before, with the biggest contradiction being the fact that they seem to be cold, they seem to have lots of ice, yet they still seem to emit a lot of infrared light right from the center, kind of resembling a typical hot star. As a matter of fact, in terms of luminosity, both objects are estimated to be
anywhere from 500 to 750 times brighter than the Sun. So yeah, these objects also seem to shine. And since there are no clouds near them and no source of any kind of ice in this vicinity, it's basically unknown where they even came from. These objects are truly isolated and relatively compact. Additional observations also reveal that there is a relatively broad emission line, suggesting that something here is moving at 8 to 14 kilometers per second. So basically here gas seems to be orbiting something more massive in the center, in some sense maybe resembling a star system after all. These velocities are very common in a lot of different star systems. Or maybe this is some kind of a gas orbiting something central, which would imply some kind of a shock event that possibly happened in the past from something, I guess, exploding. But once again, since there are no nearby star-forming regions and no clouds of any kind, it's impossible to explain the origin of these two objects. In the study, researchers actually focus on two potential explanations. Maybe these are protostars, or basically baby stars, such as young stellar objects, and here the observations don't seem to resemble any of them. Likewise, maybe these are ancient stars or evolved stars, basically near the end of their transition, but once again, we cannot explain what's evolving into what, or even what sort of a star this would be, with the only possible explanation that the researchers provide at the end being some kind of a dust-enshrouded, oxygen-rich AGB star, or basically some kind of an enriched infrared star that for some reason contains huge amounts of ice. And the additional explanation basically just being some kind of a coincidence, as in there is a cloud here, very small ice cloud, and maybe just maybe right behind this cloud, somewhere really far away, there is basically some kind of a bright star that's shining through this cloud, making it appear like it's the same object. The only problem with that explanation is that we have two objects doing this, and they both resemble each other quite a lot. So yeah, that would be quite a coincidence. And well, right now, this is pretty much where we're at. We have these two unknown icy objects, somewhat hot and bright on the inside, very cold and icy on the outside, that don't resemble any star, don't resemble any cloud, don't resemble absolutely anything. We don't have a name for them, we don't have any information about what this can possibly even be. These are just two icy balls, surprisingly in a similar location in the night skies, but separated by about 10,000 light years of space. And intriguingly enough, there's not even a single theory or explanation out there that can maybe start resolving this mystery. Normally when we find some kind of a mysterious object, there's at least one paper somewhere out there that might have predicted their existence. Here though, not so much. This is really a bizarre mystery. And actually a super exciting mystery because for all we know, we might have discovered a completely new kind of star. A star that for some reason has been never found before, has been kind of ignored I guess, but in this case because we have two, this might actually be it. An entirely new cosmic object, discovered completely by accident by analyzing older data. But in order to understand what's happening here, two things need to be done. The first, more obvious, is observations with the James Webb. James Webb was basically designed for these types of observations, and it's going to tell us exactly what's happening inside by observing various molecules and by helping us understand how things are distributed inside this object, which could then allow us to maybe simulate the overall structure. And second, it's important to compare these two objects and to find individual differences, because this will also help us see what might have happened here and how these objects might have formed. Lastly, we need a wider survey trying to discover even more of these objects somewhere out there, because chances are this is a new type of a star, and chances are they're actually everywhere, but for some reason were never seen before, maybe because people didn't actually think this would be a new star or a new object. And that's because previous infrared surveys never really looked that far and never really had enough resolution to identify such small objects at such distances. Now though, with the James Webb, once we have a hint of one of these objects again, it will be possible to determine exactly what's inside. And right now the scientists behind the study applied for James Webb observations in order to essentially try to solve this mystery. Which means that in the next few months, hopefully, we'll hear back more about this and maybe have our first answers.
And today we're going to discuss a relatively new study that potentially provides a really exciting explanation to at least two separate mysteries coming from the center of our galaxy, and specifically somewhat unusual observations and somewhat unusual emissions that for decades now have been sort of confusing everyone. Mostly because these observations were essentially an anomaly. And so in this recent study, Pedro de la Torre Luc, whose name I'm sure I mispronounced, actually provides us with a really exciting explanation that there's a very high chance that what we're observing is potentially the mysterious dark matter. And so let's talk about this in a little bit more detail, because technically this would be some of the first observation of dark matter particles coming from the center of the galaxy. But before we start, let's discuss the mysteries and why this is kind of important. And that's because for many decades, scientists observing the Milky Way galaxy discovered something bizarre. And so here this is actually coming from the region known as the CMZ, Central Molecular Zone, a very large part of the Milky Way center that contains 60 million solar masses of dust and gas and is essentially filled with giant molecular clouds and quite a lot of different activity. We've actually discussed some of the previous discoveries about this region in some of the videos in the description. Naturally, this is also where the central massive black hole is located as well. You can sort of see it right there. But here, for many years, researchers have also been discovering just a little bit too much energy. And specifically, by analyzing these clouds, and by looking at the emissions from a lot of this gas, over the years scientists established that there seems to be an excess of what's known as ionization. Or in other words, even though technically hydrogen should basically be neutral gas, here there was an excess of ionized hydrogen pretty much everywhere. And it was not just hydrogen, it was also molecules of water and even things like methanol. So basically here, for many years, in many different locations, scientists kept discovering a significant excess of ionized molecules that would basically require an extremely large injection of power at all times. So this could not be explained as a single event, such as, for example, active central black holes or even occasional supernova. Whatever was ionizing this gas, it seemed to be happening in real time. And though some of the previous explanations suggested that maybe this was basically coming from the cosmic radiation or cosmic rays, a lot of different studies established that cosmic rays were just not enough. Here, the amount of energy was just a little bit too much, and so the source of this anomalous ionization was somewhat difficult to resolve. Although naturally there's been a lot of different propositions from a lot of different studies. So far though, nobody actually knows what's causing all of this. And obviously something similar has been observed in a lot of other galaxies, but because they're much farther away, it's usually difficult to tell what's happening there as well. For example, in many cases, it has been attributed to the central active black hole in the center, like in this galaxy right here. But because the Milky Way galaxy doesn't have an active black hole, and the black hole here has not been active for some time, it would be somewhat difficult to explain why so many clouds in the central region seem to be ionized. And so that's mystery number one. Then there's a completely separate mystery that's sort of unrelated to this completely, but also involves very high energy particles that cannot be explained. And here this concept is known as 511 keV line emission. In this case, 511 keV refers to 511 kiloelectronvolts, or the exact energy of various photons detected from various locations around the galaxy. This is sometimes referred to as the gamma ray line emission, although because the energy is actually kind of low, it's also been referred to as an X-ray emission line. And the thing is, some of the first observations reveal something unusual happening in the center, or essentially revealed that this unusual emission line seemed to be concentrated in certain regions. Now, the specific energy here is very often attributed to positron annihilation. In other words, when a positron combines with an electron, it very often produces these photons with 511 kiloelectronvolts of energy. And the first signature of this positron annihilation was actually seen back in 1970s. But surprisingly, it was all coming from the galactic center. And pretty much since then, the source of these galactic positrons remained more or less unknown. This essentially became known as the 511 keV puzzle. But some of the more recent observations detected the emissions coming from a lot of parts of the galaxy, even from the disk itself. So essentially here there was an unusual source of these positrons produced at all times everywhere in the galaxy, with a large source right in the middle. And once again the production rate, or the annihilation rate, was really high, requiring huge amounts of energy produced by something at all times. And so over the years this became the strongest persistent galactic gamma ray line that seems to be coming from the center of the galaxy no matter what, with the largest source being right in the middle, basically right in the center of this central molecular zone. And so something right in the center was causing electrons and positrons to continuously annihilate, here we're talking about antimatter annihilation, and to basically continuously produce huge amounts of energy. But it made no sense that it was in the galactic bulge and not anywhere else. As a matter of fact, additional research discovered no point source in this case, so this was not coming from the central black hole, but was more or less distributed in a way where the density was the highest in the center, but decreased as you moved away from the center, in essence making it look something like this. And naturally, over the years, quite a lot of explanations have been proposed, but most of them did not satisfy everyone, or would always have some kind of an inconsistency. Now, for example, one explanation for the detections from the disk, the ones that you see in purple, suggested that this could be attributed to various radioactive elements, such as isotopes of aluminium and titanium. This would be the result of various supernovae over time. And though this could explain some of these detections, it once again does not explain what's happening in the center, because we don't actually see that many supernovae in the center, and because we should also be seeing concentrations of these elements in certain molecular zones where new stars are constantly formed. This would apply to, for example, the Orion Nebula. And so here, this bulge emission seemed to arise from something entirely different, and was very likely not the result of any radioactive isotopes, with additional explanations suggesting that maybe this was a result of type 1 supernova, or even smaller black holes orbiting various stars, so in this case X-ray binaries, but because we don't actually expect that many in the center, this once again did not make much sense. And so this bizarre 511 keV mystery essentially stayed completely unexplained for approximately 50 years now. But this new study proposes that both of these mysteries could be solved if this was indeed some kind of a particle, specifically a relatively light particle, that would also be responsible for the mysterious dark matter. Or to be more exact, they propose light dark matter annihilation as the explanation for this and for the highly ionized gas visible everywhere. Although here, it's important to clarify that this would not be a massive dark matter particle, such as the one known as WIMP or weakly interacting massive particle, because in this case, these observations can only be explained if this is a very low in mass particle that's able to self-annihilate and able to produce certain emissions, which then result in the production of antimatter and also result in the production of highly ionized gas. But because in this case we expect dark matter to represent approximately 85% of all matter in this region, even a small portion of these particles annihilating over time would definitively explain the excess of energy. And so the energy signatures coming from the center of the Milky Way, that also seem to be relatively constant and don't actually change much over time, could easily be explained if this was indeed an extremely large amount of self-annihilating particles. Specifically particles whose total energy is below 1 gigaelectron-volt, but also particles that would be maybe more massive than the mysterious axions. You can learn about axions in one of the previous videos in the description. Naturally though, because here we're talking about dark matter, since it doesn't really interact with anything and doesn't produce emissions by itself, the only way to detect it is basically by observing the effects on the matter nearby. And so as these tiny particles occasionally combine or interact with each other in such a way that they cause self-annihilation, they then end up producing new charged particles that then ionize the gas around them. But once again here, the dark matter particles would have to be of a very specific mass. The mass that has not been actually explored that much yet. But if the study here is correct, it would once again solve at least two mysteries all at once: the mysterious gamma ray emissions and the mysterious ionization emissions, while also giving us a hint about dark matter particles and potentially what they're made out of. But in order to confirm this, one of the first things that needs to be done is what's known as a spatial correlation, or essentially a detailed observation and a very thorough analysis of the 511 keV emissions compared to the emissions of the ionized gas. Because if this is caused by the same phenomenon, we expect a very large correlation between molecular clouds and the positron line emission, along with potentially other emissions that can be created by these interactions. Now, since this has not been done yet, we obviously have no idea if this is correct, and even if these correlations are discovered, there might still be an additional explanation. And today we're going to discuss a somewhat interesting discovery in regards to a massive structure in the Milky Way galaxy that apparently the solar system has passed through in the last 14 million years. And more importantly, there seems to be a connection with something that potentially happened right here on Earth. Something that might have even affected the climate on the planet and possibly caused an extinction event. And so let's talk about this new study about the mysterious Radcliffe wave once again. But here, let's actually start with the wave itself first, if this is the first time you're hearing about it. And by the way, the video in the description talks about the original discovery from back in 2020. But basically, Approximately 5 years ago, from when I'm making this video, scientists using Gaia telescope officially confirmed that there's a really bizarre structure that seems to form an unusual connection between a lot of famous molecular clouds known to us. And you can actually explore this structure in 3 dimensions by yourself by using one of the links in the description. Now the sun, as you can see, is right here, and this is the wave. The wave containing things like, for example, Orion molecular cloud, and actually 56 additional clusters and various star-forming regions which have been known to us for a very long time, but we just didn't really know that it's all part of the same structure. And so inside this wave, there are a lot of different, relatively dense clouds of gas that is then compressed to form new stars, which is exactly how the solar system was born as well, approximately 4.5 billion years ago. But interestingly enough, this is actually a really large structure. It's approximately 9,000 light years across, and it also seems to literally wave. This was actually confirmed relatively recently, and you can learn more about this in the video in the description. And so strangely enough, this wave contains a lot of star-forming regions, including the famous Orion complex, but also other famous regions like Perseus and Taurus, with Taurus actually being the closest to us at approximately 400 light years. And basically the overall environment inside this wave seems to be somewhat complex, way more dense, with the overall density of gas generally being much higher compared to some of the nearby regions. But we don't really know much else about this unusual Radcliffe wave, because first of all I guess it's a recent discovery, but second of all there's just not much else around it to even explain how it was formed. Now one of the potential explanations involves some kind of an ancient galactic collision, but we just don't know which galaxy, but it could also have been formed as a result of a massive chunk of dark matter interacting with the galaxy as well. In other words, because this is a wave and because it's rippling, here some kind of a collision seems to be the best explanation. But it was really the exciting new discoveries from this study, the study by Marconi on the solar system's passage through the Radcliffe wave, that kind of raised a lot of intriguing new questions. And so here, by using a lot of data from the Gaia telescope and combining this with spectroscopic observations by other telescopes, in this case by using surveys like LAMOST and SDSS, researchers were able to actually determine the overall passage of the solar system in the last 30 million years, almost definitively confirming that approximately 14 million years ago, the solar system might have actually passed right through the wave and very likely extremely close to certain regions that were actually producing a lot of stars. And that's obviously because we know that everything in the galaxy is always moving around and is always shifting, as for example the solar system orbits the Milky Way at approximately 220 km per second. And this was achieved by tracing the movement of 56 open clusters inside the wave, and then comparing this to the motion of the solar system in the same period of time, with the study confirming that the solar system passed through the Radcliffe wave 18.2 and 11.5 million years ago, but the closest approach actually happened 14.8 and 12.4 million years ago. And what's actually interesting is that 14 million years ago, it basically looks like the solar system passed extremely close to, or possibly even through, the entire Orion star-forming complex, one of the most active star-forming regions that's existed for several million years. And because the environment in this region is much more dense, here the main assumption is that during this passage, all of the interstellar dust potentially created way more pressure on the sun's heliosphere, possibly even decreasing it in size. But this would also increase the overall amount of interstellar dust in the solar system, increasing the overall amount reaching the planet, but also increasing the amount between Earth and the Sun. And here there's actually a somewhat intriguing implication from the study, but it's not something that can be proven yet. The implication that not only did this leave some kind of a geological record that actually can be discovered in time but has not been found yet. In this case we're talking about, for example, various supernova that potentially happened nearby. Here, because the solar system was suddenly in a very different galactic environment, it possibly influenced the climate on the planet as well. And here researchers do propose one possible connection. The connection between this passage and the so-called Middle Miocene Disruption, MMD. The event that happened approximately 14 million years ago and eventually resulted in the growth of ice sheets in Antarctica. But more importantly, it's also connected to a somewhat prominent extinction event, which affected various terrestrial and aquatic life forms, which were doing really well millions of years prior. And specifically, they were doing really well during mid-Miocene climatic optimum, which was then followed by this unusual drop in temperature. This is when the climate was pretty warm, and this is when the tropics expanded quite dramatically, with the planet becoming super hospitable in a lot of regions, including Antarctica. But 14.8 to 14.5 million years ago, everything suddenly changed. And though this is not a causational relationship, or basically this is just a correlation, it just so happens that according to this study, this also seems to coincide with the passage through this Radcliffe wave extremely close to the Orion molecular cloud, with the implication being that maybe the extinction and the cooling of the planet are somehow connected to this Radcliffe wave event. But the thing is, we don't really know exactly what would happen and how this unusual cooling would be achieved. So, for example, when it comes to interstellar dust, in order for this dust to affect the planet, and in order to produce the cooling we seem to observe, the density of dust and gas inside this wave would have to be a million times higher than what we actually observe right now in the solar system. But based on the observations we have so far, this doesn't seem to be the case. So if it did affect the planet, it probably had to be in some other way. But here, in order to provide more evidence, we would need more details from paleoclimatology, or basically the science of finding fossils that can show us what happened back in the days. Right now, there's no evidence for anything yet. I mean, for all we know, maybe there were actually a bunch of supernovae nearby that could have caused a dramatic drop in temperature, but here we would have to find signs of some kind of an isotope, like for example iron-60, that would have to be in deposits from around this time. Once again, nothing has been discovered yet. Nevertheless, what the study suggests is that for millions of years, the solar system was actually passing through a lot of famous star clusters. For example, this gorgeous region you see right here, known as NGC 1977, or this other region in the Orion molecular cloud, known as NGC 1980. And so because the solar system was relatively close to them, there might have been some effect on the heliosphere, and thus the effect on the planet, which if confirmed would make this a really intriguing discovery. It would basically confirm that certain types of global cooling could have been caused by passages through various molecular clouds and could have affected the planet in ways we never knew before. Now, some of the previous papers actually already suggested that previous glaciation events might have been indeed caused by various molecular clouds and even potentially happen every 100 million years, but this new study provides the first potential evidence that there might be indeed some connection. Although the reality is that unless we actually have some kind of a model that can be then tested, it's still going to be a hypothesis for a very long time. Like I mentioned, one of the main reasons scientists don't actually think there was a direct effect is because you would need millions of times more dust in order to affect the planet so much that it actually starts cooling. And the current observations do not provide any evidence for any of this, which kind of makes this a super exciting correlation and a very intriguing discovery, but not really an explanation for anything yet, which is exactly where we have to leave it at. Here we cannot assume that some kind of a molecular cloud can dramatically affect the climate of planet Earth, and we can obviously not make any assumptions about the current climate change on the planet either. As a matter of fact, the scientists specifically mentioned that the human-driven climate change is incomparable and is happening on a timescale of decades as opposed to millions of years, like in this case. Still, a somewhat exciting discovery, and maybe a potential explanation for why Antarctica exists as an ice sheet and not as a continent filled with animals like millions of years ago. In other words, this potentially explains the large-scale glaciation of the entire Antarctica continent. But at least for now, that's kind of all I wanted to mention. Hello wonderful person, this is Anton, and today we're going to discuss a solution to a relatively interesting radio mystery. Basically, a mysterious signal that was discovered not so long ago that actually seemed to repeat with a very unusual period. Although here, unlike previous detections, this was also a relatively long signal that appeared to come from a location we've never seen before and resembled something entirely different from previous detections. And so in other words, even though we already have a mystery of fast radio bursts that are still difficult to explain, here we now had another radio signal that was even more mysterious and even more unusual. But now, after several years, scientists potentially solved this once and for all, with this explanation also maybe applying to some fast radio bursts as well. And so let's discuss this in more detail, and I guess let's start with the signal itself and why this was so mysterious. First of all, unlike FRBs, this actually seemed to be coming from somewhere much closer. This signal appeared to be coming from the Milky Way galaxy itself. And to date, we've only discovered one single FRB in the Milky Way. You can learn about this in one of the videos in the description, and by itself that signal was very different and only lasted for a fraction of a second. But when studying fast radio bursts, researchers have also discovered repeating FRBs that seem to repeat every few days, always coming from the same location. And though there are quite a few explanations for a singular FRB, the repeating FRBs have always been a bit of a mystery because it's actually unknown what kind of a mechanism could produce these signals and why they would be repeating at all. And so to try to solve some of the mysteries of these radio signals, researchers decided to basically go through some of the older data collected by radio telescopes in order to see if they can also discover longer signals that are not just microseconds, but are possibly seconds or even minutes long. Here they used what's known as LOFAR, which stands for Low Frequency Array, or essentially a very large radio telescope operating at the lowest radio frequencies accessible from Earth, with several main stations located in Europe. And here they focused on radio signals collected as far back as 2015, in the process discovering quite a few, but one of them really stood out, because here they found a long period radio signal that also lasted much longer than a typical FRB. And though the shape of the signal resembled a fast radio burst, the length did not. And so there were definitely some really bizarre differences, with one major difference being the strength. A typical FRB is actually ridiculously powerful. And because of this, the mechanism producing it has always been connected to some of the most powerful objects in the entire universe, in this case magnetars, magnetized neutron stars that seem to be the only objects capable of such extreme energies. And because of these powers, they can actually be seen from billions of light years away from us, which is why so many have been discovered in just the last few years. But here, instead of having something very powerful and extremely fast, we had something less powerful and very slow. This unusual pulse, now referred to as ILT J1101 plus 5521, seemed to always last at least a few seconds, although usually closer to about 40 seconds. But much more interestingly, it repeated with almost exact period, 125.5 minutes, with several definitive detections visible in the last 10 years. And because it was coming from the location in the Milky Way where we don't actually see any magnetars, and do not detect anything else related to neutron stars, here this seemed to be produced by something entirely different. And though different, this was still intriguing enough because it could actually help us explain certain FRBs as well. And it wasn't until very recently that scientists finally discovered what's causing this. Iris de Ruyter and the team of researchers you see right here, whose names I'm not going to be butchering this time, was able to finally discover what's happening here by using the Multiple Mirror Telescope in Arizona and the McDonald Observatory in Texas. Basically here, by using optical telescopes, they finally discovered a tiny object emitting everything. Because in this case, this was a very faint star, and a star at a distance of 1645 light years away from Earth. And the star was a red dwarf, basically the most common type of a star in the Milky Way. But the question is, why was it doing this? And so by observing this star for at least 2 hours, in order to detect at least one of these signals, they realized the star was doing this. It was basically moving back and forth just a little bit, which of course implied only one thing. It was orbiting something else, but something that was even more difficult to detect, and something that was clearly not a black hole, and very likely not a neutron star. Something much less massive in mass, but something that was still difficult to detect nevertheless. And the only thing that kind of makes sense is, of course, a white dwarf. Which would naturally make quite a lot of sense because a typical white dwarf-red dwarf system is not that unusual either. And so because of their very tight orbit, that basically only takes 2 hours, here they seem to interact in such a way that every 2 hours they release massive amounts of radio waves. And though at first some of the explanations suggested that maybe this is actually something that's spinning every 2 hours and emitting waves because of this, since the red dwarf has now been confirmed to be orbiting something, a white dwarf partner makes way more sense. But why exactly do they produce radio waves? Well, one of the main explanations is the interaction between their magnetic fields. We know that red dwarfs can have pretty powerful magnetic fields, but white dwarfs can be even more magnetized and even produce their own radio signals similar to pulsars. We actually discussed some of the previous discoveries of these bizarre white dwarf pulsars in some of the videos in the description. And so if both objects contain powerful magnetic fields, every time they come slightly closer together, the density waves from these fields probably collapses into one another and creates these enormous shock waves that are then released as massive radio waves traveling across the galaxy. Which potentially implies that maybe their orbits are slightly elliptical, and maybe the interaction between these objects in the past made them so magnetized to begin with,
And here there's actually one question that is not answered, but would be very important to answer in the future. How exactly did something like this form? Now, this white dwarf was probably somewhat similar to our Sun in the past, and eventually became a planetary nebula before turning into a white dwarf. But because its partner is orbiting so close, it's quite likely that something major happened in the past when the stars were interacting with one another in order to create these very extreme conditions. For example, when the white dwarf was still a red giant, its partner would have been inside the star, basically shredding it from the inside, very likely causing some major disturbances that could potentially explain certain red giants out there. Alternatively, maybe this red dwarf was actually much larger before as well, and here the white dwarf might have consumed its outer shell over time, producing many nova in the past. And what we're seeing now is basically a remnant, where there's now a much smaller star and a white dwarf that no longer produces nova, but still produces powerful emissions, because it's now become so extremely magnetized. And so the origin of this system would be kind of interesting to investigate. But because this system now produces radio pulses, it does suggest there is no more accretion, and the white dwarf is no longer feeding. But generally speaking, these highly magnetized white dwarfs with partner stars are usually referred to as polars. These are types of cataclysmic variable binary systems, where an extremely high magnetic white dwarf manages to accrete material from a star with a much lower mass. So in some sense, maybe this is just the end product, or essentially we've detected the polar that finally stopped accretion. And so here only future observations will provide us more answers on how exactly all of this works. But right now, this is basically the first official explanation for one of these long period transients, also known as LPTs, that have been officially identified a few years back. With one of the main breakthroughs in this study being the ability to pinpoint the exact location by using a combination of radio telescopes that sort of acted like an enormous radio camera. This is how they traced the emissions to this particular star. And because now we know that compact objects that are not neutron stars can also produce these bright radio emissions, this can potentially explain certain radio signals that were previously unexplainable. But now we at least know that some radio signals definitively come from binaries and seem to be formed through the interaction of magnetic fields. And today we're going to discuss a somewhat exciting discovery in regards to one of the most mysterious features in the Milky Way galaxy. The feature that you sort of see right here. These are known as galactic center filaments. Super bizarre tentacle-like formations that seem to be present in a lot of different galaxies, but much more importantly, that seem to be all over the Milky Way galaxy as well. And though we've actually discussed these features several times in some of the previous videos, even today, as of 2025, after several decades of research and observations, researchers still have absolutely no idea what exactly this is, how it's produced, or even what's inside. And though you can learn about some of these new discoveries in a few recent videos in the description, mostly because some of the recent discoveries were only made a few years ago, and because of new advances in radio telescopes, in this video we're only going to focus on one of these filaments, the one whose name you see right here, and the one that seems to be the longest. It's also one of the filaments that has a proper name. It's basically known as the snake. But more importantly, we're going to discuss some of the recent discoveries that sort of hint at possibly how these filaments are created, or at least show us why certain filaments seem to contain bizarre features. And so let's talk about this in a little bit more detail, but here I guess let's briefly start with a bit of a history. Because despite all of this being somewhat mysterious and somewhat poorly understood, this is definitely not a new discovery. Because the first observations and the first discoveries were back in 1984, and this was of course found completely unexpectedly. As a matter of fact, initially, this was actually believed to be either some kind of an artifact or some kind of a pixelation, and was believed to be a botched observation. Or in other words, this was believed to be not real. But following additional observations by multiple groups, and also observations using multiple wavelengths, hundreds and eventually thousands of these filaments were discovered all over the Milky Way, with some of the largest, longest, and most pronounced filaments mostly being in the center of the galaxy, which is why they're usually referred to as galactic center filaments. But they all seem to be only visible in radio light, suggesting that they possess extremely strong magnetic fields and possibly emit what's known as synchrotron radiation, or basically radiation emitted by particles moving extremely close to the speed of light in somewhat magnetized conditions. Usually these particles are electrons.
But the source of these particles, and really pretty much everything about the mechanism of the formation here, is completely unknown. For example, in this image you can actually see some of the circular structures, and these structures we can usually explain. You can actually learn about this in one of the previous videos in the description, but usually these are results of supernova or some really massive eruptions from some kind of a really powerful object. But the filamental objects are very difficult to explain, especially when they have these super bizarre shapes. But more recently, in the last 2 years, researchers also discovered that apparently they come in two different types. They seem to be either vertical or horizontal. And both vertical and horizontal filaments contain slightly different properties. You can sort of see a mixture of both in this image right here. And so the horizontal filaments, which run parallel to the galactic plane and normally away from the galactic center, very often also appear to emit thermal radiation, or basically they're also visible in the infrared light. This is believed to be the result of some kind of an acceleration inside various molecular clouds. And here it's possible that their origin is actually the result of emissions from Sagittarius A star, the central black hole. So basically these horizontal filaments could be the result of super ancient black hole emissions. Emissions that essentially started to interact with a lot of gas around the black hole, possibly ionizing this gas and causing it to accelerate away from the center, forming these very strange lines. And normally these lines are 5 to 10 light years in length, but are also much lower in total number. In contrast, the vertical filaments seem to be entirely different. First of all, most are super long. Some of them can reach length of up to 150 light years, or basically 10 to 15 times longer. At the same time, their position is almost always perpendicular to the galactic plane. Now, some of them do have a bit of an inclination, but the majority are basically practically vertical. And in most cases, all of these vertical filaments seem to possess very strong magnetic fields, basically serving as a kind of a particle accelerator, which is why we can even see them. And strangely enough, many of these vertical filaments very often come with partners or even come in pairs and do actually form these really bizarre shapes that are somewhat difficult to explain if this was just magnetic lines from the galaxy itself. In other words, whatever is happening here is still extremely mysterious and poorly understood, with a somewhat irregular spacing, as if something separated them with a very specific distance. Moreover, additional analysis from other galaxies suggested that something similar exists there as well, very often somewhere near the center, and very often forming somewhat similar bizarre filaments and bizarre patterns. And so because of this, over the years there's been a lot of different propositions. For example, back in the days it was assumed that maybe this is actually signs of these mysterious cosmic strings, ancient formations from the early universe, resembling a kind of a crack in the space-time itself, produced during the expansion of the universe. But because usually strings are expected to oscillate and produce a lot of gravitational waves, as well as maintain their shape over time, here the observations did not make sense, mostly because a lot of these filaments seem to split. And it's actually these unusual deformations and these bizarre splits that can actually explain to us what's going on here, which is essentially the main focus of this recent study. Here the focus was on these bizarre kinks that many of these filaments sometimes contain. But here the focus is on the snake, one of the longest, brightest and most spectacular filaments that contains two kinks within its total length of about 230 light years. So yeah, this is a super long object. And here we have what's known as a major and a minor kink, or basically deformation, where this filament seems to be distorted from its somewhat linear magnetization, as if something is present in this particular location, disturbing the magnetic lines. And so in a very thorough study you see right here, the main researcher, SgrA, analyzed this deformation by using several different telescopes and actually did discover the potential source for what's happening here, in the end even presenting a potential explanation for how these filaments form. Here by using the Chandra telescope, the XMM telescope, new stars, and of course the observations by radio telescopes, researchers didn't just detect radio emissions, they also detected X-rays. And specifically, the new observations looked something like this. There was actually something next to the filament, with further modeling and analysis revealing that this kink was possibly formed by something really dense, really powerful, and something moving very fast. And so here the X-ray emissions actually revealed to us a pulsar, detecting through the X-ray emissions very close to the snake and super close to its major kink, with the conclusion from the study basically suggesting that this was very likely formed when a fast-moving pulsar moving at approximately 500 to maybe even 1000 kilometers per second, passed through the snake or extremely close to it, distorting the magnetic structure in the process. And so here this pulsar, now referred to as G359.13, seems to be the origin for this bizarre deformation. It essentially perturbed the magnetic field, resulting in this somewhat strange shape. And this has now been confirmed to be a pulsar, both in the X-ray emissions and radio light, which potentially suggests that this is something that happens in a lot of locations, because we see these all over the place. But here the other proposition is actually in regards to the origin of the filament itself. In this study, researchers also suggest that there is a high chance now that these filaments might be the result of a very strange phenomenon coming from pulsars themselves, and specifically the phenomenon referred to as pulsar wind nebula, PWN. And in this case, this is based on an older proposition on the formation of these bizarre filaments. Here it's possible that some of these vertical filaments could form as a result of various pulsar wind nebula, or these extremely powerful clouds produced by pulsars, interacting with various interstellar magnetic fields, which then basically form these extremely long and extremely powerful vortices, kind of like these galactic tornadoes. In other words, the fact that there is a pulsar in this region, and the fact that it seems to be responsible for at least part of the shape, basically suggests that there's a chance that it might have produced the entire structure. In this case, through the injection of synchrotron-emitting electrons into various magnetic field tubes as the pulsar and the pulsar wind nebula pass through this region. And if so, or if this hypothesis is correct, it would basically suggest that all of these filaments are possibly the result of various pulsars interacting with magnetic fields from molecular clouds. And since neutron stars are usually some of the most powerful magnets in the entire universe, here they should be able to form some really bizarre structures as they interact with various magnetic fields. In other words, the discovery of this pulsar inside the snake currently presents us with a somewhat intriguing explanation for all of these strange vertical filaments. And so maybe, just maybe, after 50 years, we finally have at least one solid explanation for what's actually happening here. Hello InfoPerson, this is Anton, and today we're going to discuss a somewhat unusual and somewhat unexpected discovery of what scientists refer to as a dark cloud. An almost entirely invisible cloud that you see right there, now referred to as Eos cloud, that seems to be located 300 light years away from us and was discovered by using a completely new method. A method that now allows scientists to detect these clouds all over the galaxy, which at least in theory will help them solve many different mysteries, including the mysteries of missing matter and the mysteries in regards to the galactic formation and evolution of stars. But let me actually discuss some of the details first and provide some of the explanations for why this matters. And here we have to start with where exactly this is located and why this is important. This is technically part of the so-called local bubble, an enormous formation at least 1,000 light years across that contains a lot less material inside compared to everything else. And in one of the recent videos in the description, you can actually learn more about exactly what was discovered here and how we believe this bubble was formed. In a nutshell though, this is a result of tens and possibly hundreds of supernova happening all at once, approximately 15 million years ago. And well, it just so happens that the Sun is currently right in the center, with the edge of this bubble containing a lot of different molecular clouds, many of them currently creating stars, and many of them being some of the most active star-forming regions in the vicinity of planet Earth. And this is where we find many different famous stars that are going to go supernova soon, including Betelgeuse. And even though now we understand the local bubble a little bit better, when it comes to these molecular clouds, there are still a lot of different mysteries. And specifically mysteries in regards to their evolution, and in regards to why some of them start forming stars, some of them don't, and of course what happens to them at the end. But we do know that many of these molecular clouds seem to be constantly assembled and constantly destroyed. So basically all of them go through a kind of a cycle, with most of the data from the Milky Way and from the nearby galaxies suggesting that a typical cloud usually starts to produce stars when it reaches certain density and when it starts forming certain clumps. And this usually happens when something disturbs these clouds, such as some kind of a collision or emissions from a supernova. And so once the cloud has enough mass and once it starts forming these overdensities, this is when it starts to produce stars, as individual dense regions collapse under gravity and create star-forming clusters. And ironically, this is a super destructive process, As you can see, all of these stars start to actually emit a lot of energy, which eventually disrupts the cloud and even destroys it in the process. And so this whole cloud will eventually result in a star cluster that practically has no gas inside. And here, only 2% of the entire mass of the cloud are going to be assembled into stars. 98% basically escapes, dispersing across the galaxy. And in the Milky Way, every single year approximately 150 million solar masses of gas goes through this entire process. But only a small fraction ends up producing stars. Except that, as I mentioned, this is technically a cycle. Following the dispersion of this gas, it does cool down again and very likely returns back to the galaxy to try to form stars again. And well, a lot of this gas has now been traced in the region you see right here. As a matter of fact, a lot of those regions you see that contain red, those are molecular clouds currently forming stars. But not all of these regions are easily visible. As a matter of fact, based on previous calculations, it was always assumed that there seems to be a lot of mass still missing. Now here we're not talking about dark matter, we're talking about regular matter, regular gas. At least half of the gas was always difficult to detect and was actually unclear where it seems to be. Now in some of the previous studies we discussed potential detections in between galaxies, but here for the first time we actually seem to have something really close to us. And in this case this is a somewhat bizarre discovery. And bizarre, and I guess unusual, because technically if you could actually see this cloud, it would be approximately this big. This is an enormous object. It seems to contain over 2,000 solar masses of hydrogen and could thus, in theory, produce at least 40 solar masses worth of stars. Now let's talk about why this is so exciting for astronomers and how exactly this was discovered. Now first of all, it's really important to understand that generally, when it comes to hydrogen clouds, they're not particularly easy to find. Now things like nebulae we can usually see pretty well because they're ionized and they do release a lot of light that's visible. But a molecular hydrogen is much more difficult to find. Here we're talking about basically H2. This neutral gas barely produces any emissions, but is also extremely important because this is your primordial hydrogen that traveled for approximately 13.8 billion years and existed since the beginning. And so even though normally neutral hydrogen emits what's known as the hydrogen line, or emissions of 1.4 GHz in frequency, overall this emission is extremely weak and makes it super challenging to trace everything or to create these beautiful maps. And so instead, in the last few decades, scientists discovered a kind of a shortcut. They realized that normally, in a typical molecular cloud, for every 10,000 atoms of hydrogen, there's usually at least one atom of carbon and oxygen, which tends to form carbon monoxide and is much easier to see and much easier to trace. And so in most clouds this is basically the main tracer. Pretty much all of the clouds we've discovered so far, and pretty much this entire map around the local bubble, was formed by looking at carbon monoxide and not hydrogen. But there's a problem with this technique. The problem being that, theoretically, there should still be quite a lot of hydrogen that's not associated with carbon and oxygen, mostly because it's basically primordial. Or in other words, because it was never affected by anything and does not contain anything except for just a little bit of helium, with this eventually being referred to as the dark clouds or dark hydrogen, something that was technically hypothetical for many years. But the researchers behind this recent study realized that hydrogen can technically become visible if it's in presence of more powerful stars or if there's something else near it, such as for example glowing nebula. Or in other words, some of this previously invisible hydrogen should become visible if there's a source of UV radiation somewhere in the vicinity. And it just so happens that this new cloud is essentially surrounded by other clouds and a lot of other powerful stars. And so in order to test this hypothesis, researchers used some of the data from an older satellite, specifically STSat-1, that was launched back in 2003, that collected a lot of UV data over the years. This was a South Korean ultraviolet space telescope. And here the focus was on far ultraviolet fluorescence that should technically be producible by hydrogen molecules if they're affected by UV radiation coming from somewhere else. In other words, they were focusing on glowing hydrogen. Now, because most of the hydrogen doesn't usually have UV sources near it, in general this molecular hydrogen will usually remain kind of invisible. But here, because of the structure known as the North Polar Spur, we get a very unique condition. You can see the structure visible right there, and this is one of the most well-known and one of the largest structures in the entire galaxy. a giant cloud of polarized emissions that seems to be produced by ionized gas inside some kind of a strong magnetic field. And whatever is happening inside the structure seems to make hydrogen inside Eos cloud glow in the ultraviolet light. Here the name Eos is after ancient Greek goddess of the dawn. And in this case, North Polar Spur even seems to change its shape. As you can see from this image, it's somewhat crescent-shaped, with the overall outline actually kind of following the emissions from the North Polar Spur. And though the origin of the spur itself are still not known, but believed to be the result of various supernova, the energy and radiation coming from it seem to be directly affecting Eos cloud. But technically affecting it in a somewhat negative way, because just like during star formation here, all of these powerful emissions are resulting in a phenomenon known as photodissociation. And so even though it's making this cloud glow in fluorescent light, it's also breaking it apart, slowly evaporating all of the hydrogen with a rate of about 600 solar masses every million years. And so in about 5.7 million years, it's most likely going to disappear. Which means that it probably doesn't actually have enough time to form any stars, and all of this gas will have to first cool down before it has another chance to form stars in the future. But I guess the main surprise here is how massive and how large this structure actually is, and of course how close it is to the solar system. As I mentioned previously, this is over 2,000 solar masses in mass and is also approximately 85 light years across. But in terms of science, what makes this study exciting is the fact that this cloud was even discovered and the fact that it was possible to measure the rate of dissociation, which will most likely allow researchers to work out how most of this interstellar gas eventually forms into stars and how it helps galaxies evolve over time. And so because of this discovery, it's now possible to find even more such clouds, which will obviously help us understand how Milky Way evolved, but also helping us discover a lot of this additional hidden gas everywhere, because chances are there are even more clouds producing similar emissions. With one of the follow-up studies also focusing on the idea of star formation. And while right now it looks like there are no signs of previous star formation, with the chances of future star formation being relatively slim. In other words, there's a high chance that this entire cloud will eventually just dissipate into nothingness. And here we're talking about a lot of gas. 2,000 solar masses. But at least for now, that's basically all we know. Although I'm sure that because of this research and because of some of the recent discoveries about the local bubble, we're going to be hearing more about this in some of the future studies. And mostly because it was really in the last 5 years or so that we actually finally started to understand so much more about this local bubble, with astronomers finally mapping it in detail. And today we're going to discuss some of the recent discoveries about this somewhat mysterious structure around the solar system referred to as the local bubble, sometimes also referred to as LHB, local hot bubble. An enormous structure approximately 1,000 light years across that seems to contain a lot less stuff than the rest of the galaxy, but also seems to contain a lot of super hot gas that seems to be millions of Kelvin in temperature in large concentrations in certain regions. But more interestingly, we know that the Sun itself seems to be pretty much in the center of this region, for reasons we only discovered a few years back. And so in this video we're going to discuss some of the recent discoveries about the local bubble, mostly made through new observations in the X-rays, but by also observing one of the most famous pulsars inside of this bubble that's producing radio waves in such a way that it actually allows us to scan the bubble by using some really intriguing physics. And so let's talk about the bubble once again, but if you actually want to learn some of the previous discoveries, there should be a video from approximately a year ago in the description. I generally make a video about this particular structure at least once a year, because it's just super fascinating. But in case you've never heard of this before, let's start with a bit of a history, and of course discuss how this was formed and what we know about it so far. And first of all, just like the name implies, local bubble is basically a really large cavity. A cavity inside the interstellar medium in the Milky Way that does resemble a bubble in some sense. And here the density of gas seems to be at least 10 times lower than the rest of the galaxy. But there is a higher concentration of gas and what we would actually call a shock wave at the edges of the bubble as well. And it's really at this edge of the bubble that we actually find some of the most active star-forming regions, including all of the regions you see right here. And that's because right at the edge, this density wave creates a kind of a perfect environment for the formation of new stars. All of this was actually only discovered not so long ago. But before we discuss more, So how do we know all of this, and what exactly do we think happened here? Well, technically, a lot of this starts with a decades-old prediction in regards to what we should be discovering inside interstellar medium. And so back in 1990s, astronomers studying the Milky Way had very specific theoretical expectations of what we should be finding around the Sun. And this was mostly based on some of the earlier detections in the ultraviolet light, mostly coming from a much older telescope known as Extreme Ultraviolet Explorer that functioned between 1992 and 2001 and uncovered a few interesting regions that seemed to be unusually active with the ultraviolet radiation. Or basically they contained what seemed to be somewhat hot regions of gas. And so as a result, there was a new proposed mission. In 2003, NASA launched CHIPS, Cosmic Hot Interstellar Plasma Spectrometer, that basically only had one main goal. It was supposed to study interstellar medium around the Sun, with the assumption that this medium was going to be very hot and potentially glowing. And so here researchers wanted to create a map of all of this gas, kind of showing us what the galaxy around us sort of looks like. With once again the assumption here being that the vicinity of the solar system is going to be filled with a lot of this really hot interstellar gas, possibly the result of remnants from molecular clouds and from various supernova. But this is not what was discovered at all. As a matter of fact, this was one of the biggest duds in NASA's history. This mission was a complete failure, because despite looking at the night skies for at least 5 years, this satellite barely detected anything. There were no chunks of glowing gas anywhere near us, and there was no interstellar medium that was predicted to exist anywhere near the solar system. And so the failure of the satellite actually revealed something entirely different. The interstellar medium near the solar system appeared to be kind of empty. And it actually took at least one more decade after this to finally figure out what all of this potentially looks like, and to also provide a final resolution to this somewhat bizarre problem. And so here, by measuring the total amount of gas in a kind of a line of sight from planet Earth, what we usually refer to as the column density, researchers eventually worked out an overall map of this region, and it sort of resembled a bubble, or a bubble of empty space or very low density space, with the much thicker interstellar medium at the edges. And it was also not perfectly spherical and seemed to possess a somewhat bizarre shape. It was also slightly thicker in one direction compared to the other, and was potentially even more different when looking at the vertical distribution compared to horizontal. With all of this actually being done by looking at very specific observations of ionized gas, and by detecting a lot of these ultraviolet emissions in certain regions of the bubble. With the next question being, okay, so what is this, and how did this form? And well, because it was so large, 1,000 light years across, it could not have been just one supernova. A single supernova can maybe produce a bubble 100 light years across, but not 1,000. But by 2019, it became pretty clear that this was probably the result of multiple supernova, possibly as many as 100, that all left quite a big mark behind. And intriguingly, it's really completely by accident that the solar system seems to be right in the middle of the bubble right now. And that's because this bubble is only approximately 14 million years old, and it's actually going to disappear in the next few millions of years. But more intriguingly, when the solar system entered the bubble, it seems to have passed through one of the edges, somewhere right here, which actually placed it in a region with a lot of potential nearby supernova. And this is exactly what we've been discovering in various sediments on planet Earth. As we've discussed in one of the videos in the description, there seems to be definitive signs of supernova approximately 6 million years ago, which is when the solar system seems to have entered this bubble. And in this case, all of these multiple supernova were very likely the result of some kind of a massive molecular cloud that possibly contained thousands of different massive stars and millions of smaller stars, with all of them eventually exploding in the span of just a few thousand years, mostly because stars created in the same molecular cloud and stars with a lot of mass usually go supernova around the same time. And these multiple explosions would create such a massive shockwave that would basically create what you see right here, an expanding bubble approximately 1,000 light years across. But what's really intriguing in this particular case is that, as you can see, because the bubble is expanding, it also creates an additional shockwave on the edge, which then leads to new star formation and new molecular regions with multiple massive stars, like for example in the nearby Taurus cloud, that are then going to explode once again, very likely around the same time, and very likely form another bubble. So in some sense, this is actually creating a kind of a chain reaction. And though it's unclear how far this will go, there is actually a chance this will eventually cover a large part of the galaxy, with each new bubble that creates new shockwaves basically resulting in more star formation. And though right now the local bubble is only about 1/100th of the size of the entire Milky Way, the effects from it will probably travel across a much larger area, with the effects potentially continuing for hundreds of millions of years afterwards, very likely resulting in some really unusual structures across the galaxy. Or at least that's what was predicted previously, and that's what the scientists assumed based on some of the recent studies. And the thing is, we do have quite a lot of evidence for these previous supernova and for the expansion of this bubble, and of course the effects inside of it. For example, recently, scientists created this beautiful magnetic field map. It basically shows us the interaction of the gas inside this bubble, confirming that it's expanding and confirming that it's moving really fast. But much more definitive observations and even more unusual discoveries came from the observations in the X-rays. This was the observations from ESA's eRosita mission, an all-sky survey in the X-rays that in this case was able to observe massive temperature gradients inside the bubble, which researchers believe were most likely caused by various supernova explosions. And so here, by using the X-rays, they were able to create a very accurate three-dimensional model of this hot gas, because in this case X-rays are produced by extremely hot gas that's millions of degrees Kelvin, that helped them discover the overall shape, and in the process uncovered something bizarre. First of all, in terms of verticality, this shape seems to be kind of cylindrical. Or I guess more precisely, it really looks like something exploded in the center and suddenly started to expand in both directions, very similar to other features, such as, for example, the Fermi bubbles. In other words, there's a hint that many of these superbubbles are potentially connected and possibly influence each other through processes we still don't understand. And so here the shape of the bubble, which is visible in blue, is definitely not spherical and seems to be much more elongated vertically, as predicted by previous studies. This is basically the result of gas expansion, and because in this case there's very little resistance above and below the galaxy, it's able to expand vertically much easier. But exactly how these unusual tunnels formed, that's a question we cannot answer. Right now the suggestion is that this is some kind of an unusual interstellar medium network that potentially transfers the gas inside the galaxy, and is possibly sustained by stellar feedback across the galaxy, but at the moment this is still not known. And technically this is also one of the most accurate maps we currently have, which was actually possible because in this case researchers got super lucky. And that's because these observations were performed during a solar minimum, when the sun was least active and produced the least X-ray interference, reducing heliospheric solar wind charge and thus reducing contamination. And so basically here we would have to wait at least 6 more years, because right now the sun is pretty active. With the additional discovery also suggesting that the galactic south seems to be just a little bit hotter than the galactic north. In this case it's approximately 20% hotter. This was probably the result of various supernova as predicted by numerical simulations, with this new three-dimensional map showing us various supernova remnants, superbubbles, three-dimensional picture of dust, and of course these bizarre tunnels, whose origin is still unknown. You can learn a little bit more about this in one of the previous videos in the description. But on top of this, extremely recently, scientists also discovered a completely new technique that can actually allow us to scan this region even better. And as I mentioned in the beginning, this involves pulsars. And in this case, this is a really famous pulsar, G0437, or the most accurate clock in the universe. Or at least that's what it used to be known as. This is a neutron star with an extremely precise 173.7 times per second pulsation, approximately 510 light years away from us. And it's a pulsar that's known to produce a very specific shock wave. Basically here, as it travels across this bubble, it pushes on all of the plasma or all of the ionized gas in the region that then creates very specific types of disturbance, specific types of turbulence, and basically a bull shock, a shock wave of heated gas that then glows red. And that's because this pulsar moves really fast. It's technically moving at supersonic speeds across the interstellar medium, which creates the shockwave effect. But because this is a pulsar, it's also emitting radio waves. And the thing is, by looking at these radio waves from a distance to a radio telescope, this literally looks like a kind of a blinking star. But because it's traveling through all of this super hot gas, this basically produces what's known as scintillation. In simpler terms, it makes the star twinkle. Now normally on Earth, scintillation or twinkling is the result of the turbulence in the atmosphere. But in this case, this scintillation is the result of the interaction with the gas between the pulsar and us. And that's because plasma, just like the atmosphere, is basically turbulent and does result in a slight scattering of radio waves as it travels from the source. And so basically here, if you were to look at this with the radio telescope, it would produce a slight twinkling of this radio source. And the thing is, this turbulence can tell us quite a lot about what's between the pulsar and us. And remember, this is 510 light years away from us. And so this is almost at the edge of the local bubble. And so by looking at the scintillation in this case, this object allows us to scan everything in the local bubble, telling us what lies between us and the pulsar. And here researchers were able to develop a much more accurate technique by using what scientists refer to as scintillation arcs. You can kind of see them visualized right here. This gives us a lot of information about all of this plasma between the pulsar and us, essentially telling us what sort of gas seems to have influenced it. And so by using 25 scintillation arcs and the observations from the South Africa's Meerkat radio telescope, scientists once again confirmed that the local bubble seems to be filled with a lot of compact plasma structures that, though previously were believed to be hot, in many cases have now cooled down. And so in some cases this gas was no longer millions of Kelvin, it was only about 10,000 degrees. And these much cooler plasma regions were technically expected if all of this was a result of multiple powerful supernovae that produced enormous turbulence, with many chunks eventually cooling down and forming compact regions. Although here exactly how these somewhat cold regions formed is still not entirely clear. Nevertheless, this was basically the first time ever scientists were able to use this somewhat interesting technique to peer inside these shockwaves in order to discover what seems to be inside this region and what the local bubble is made out of. With all of the evidence so far, confirming once again that this is a result of multiple supernovae approximately 14 million years ago, with some of these supernovae leaving the mark in the sediment on planet Earth. But exactly what the bubble is made out of and exactly what's happening inside is still an ongoing mystery. As a matter of fact, it will probably take decades of observations in order to find out what else is hiding here, in order to explain a lot of these tunnels and the overall shape of the bubble, and to also figure out why some structures here seem to be much colder and much more compact. And if you want to find out more about the discovery using the pulsar, it's all in this study by Daniel Reardon. Today, I wanted to discuss one of the strangest discoveries coming out of the Gaia Space Telescope. A discovery of a very strange family of stars we've never seen before that's currently extremely difficult to explain and seems to be the first such family discovered in the last few decades. And so in this video, let's discuss exactly what Gaia discovered and of course talk about what this means, why this is important, and what we know so far. But first, let's start with the study. As always, you can find this in the description. But here, the study by Dylan Hewson and the team you see in front of you, researchers were able to use the data from Gaia telescope in a completely new and somewhat exciting way. And in case you are not familiar with this mission, or in case you don't know what exactly happened here, up until relatively recently, Gaia was one of the most complex space telescopes by the European Space Agency. And I'm saying was because this mission was recently finally retired. And during this time, Gaia observed billions and billions of different objects moving across the night skies and used a technique known as astrometry to observe precise motion of each individual object. And here astrometry is basically a technique where you try to find minute motions of something as it either moves or wobbles as a result of gravity. And Gaia was able to do this, or basically to observe this motion, for billions of different objects, even discovering exact distance to each of them and providing a lot of additional data. You can learn about some of the major discoveries from this mission in one of the recent videos in the description. But during years of operation, Gaia was able to observe so many objects and collected so much data that even now only 3 data releases have been completed. We actually expect the 4th release sometimes next year in 2026, and the last one possibly in the next 5 years from today, so possibly at the end of 2030. And that basically highlights how much data this telescope was able to collect and how many various objects it was able to analyze. And when it comes to our own galaxy, one of the main discoveries coming from Gaia was really in regards to discovering various types of structures and various types of star families that could now be connected into one single image and could now be used for basically galactic archaeology, or essentially to discover how the Milky Way galaxy evolved over time by discovering these literally ancient bones inside the galaxy represented as various stellar streams and stellar families. And that's because normally a lot of stars start their life together and very often also continue their life as some kind of a cluster or some kind of a constellation of stars. And so for some star clusters it may take them millions or even billions of years to finally fall apart. As a matter of fact, for a smaller, average-sized star cluster, it might take it approximately 200 to maybe 500 million years to completely dissipate. But until then, they usually travel as a single group, which Gaia telescope was extremely good at detecting. And so in the last few years, researchers observed various strings of stars and various star clusters stretching across the entire galaxy, forming these ancient structures. Many of them, like the famous stellar streams, turn out to be leftovers from ancient destroyed galaxies. Galaxies that combined with the Milky Way. But in this recent study, researchers decided to focus on something slightly different. Here they developed a new model to explore the Gaia catalog by focusing on younger, low-mass stars in a relative proximity to the solar system. And so they created a model known as Gaia-Net, a model that was able to go through millions and even billions of different stars in a catalog and identify specific members based on very specific parameters. In this case though, they mostly focused on young stars. Stars whose age was less than 20 million years old, suggesting that all of them were baby stars, barely developed and still forming planets. And strangely enough, approximately 1,000 stars really stood out. Here they identified approximately 1,000 members inside one of the families that made absolutely no sense. Here this was detected inside a famous association known as Scorpius Centaurus, one of the closest OB associations to planet Earth, known to contain quite a lot of really massive, really hot stars. And in this case, this is relatively close to us at a distance of anywhere from 400 to 600 light years away. Intriguingly, this is also at the edge of the local bubble, the structure we recently discussed in one of the videos in the description, because something exciting was discovered about that as well. You can find the video somewhere right there. But here, this association seems to contain quite a lot of young stars, anything from approximately 11 to maybe 15 million years old, with many different stars forming star clusters, or basically star families, representing stars formed around the same time. And well, normally they'll look something like this. All of the stars are going to be in a very similar region and are obviously going to be almost exactly the same age. And they often have very similar motion and are also gravitationally connected, allowing them to maintain the structure and preventing them from falling apart for millions and sometimes billions of years. But this new star association or this new star family didn't match anything else. It's now referred to as Ophion, a very massive association of approximately 1,000 stars that all seem to be very similar and seem to have formed around the same time, but are all moving in very different directions. Or just to rephrase this, unlike other star associations or other star families, here the stars are not gravitationally connected at all and are actually dispersing across the galaxy in what seems to be record time. But based on the observations from Gaia and the further analysis, all of these stars seem to be basically from the same molecular cloud, or in other words, they were formed at the same time in the same location. Yet their motion is very different. They're all moving in very different directions, with the study suggesting that this entire region is going to be practically empty in the next few millions of years. So it's as if something completely exploded and completely destroyed an ancient star cluster. And for such a huge family of stars, this is super unusual. As a matter of fact, from what we see so far, this family seems to reside alongside other families or other massive star clusters that seem to be still connected and seem to be still together. And so we don't really know exactly what happened here and why this unusual family completely fell apart and is being dissipated within just a few million years. But naturally there are maybe some hints, or I guess some explanations. The main one right now is possibly a set of really massive explosions. And that's because here, at a distance of 650 light years away from us, we do see signs of somewhat recent supernova and somewhat recent energetic events. And so basically, if there was a number of really massive explosions happening around the same time, they could have a chance to maybe disperse everything all at once. And so because the evidence for ancient supernova seems to be there, this is the best explanation, and actually maybe the only explanation we seem to have so far. But if that's the case, we should be seeing this way more often in a lot of other systems as well. Yet at the moment this is the only such family discovered from the entire Gaia catalog, and so it's not entirely clear why here and not in other molecular regions. As a matter of fact, the supernova in other molecular clouds have never really disrupted all of the stars. there's always at least a few stars that are left, and at least a few stars should still maintain the cluster. As a matter of fact, this discovery potentially redefines how we think star groups and star clusters form and how they maintain themselves over time, and possibly redefines the idea of star families and star associations. Because here, even though this is a family, it's not clustered together, and every single star, despite being very similar, seems to be basically completely by itself. And if it wasn't for the Gaia telescope, it would have never been discovered. Here it's only visible because of super high quality data, and because of the very high observations of spectroscopy mixed with the star motion, which then allowed the researchers behind the study to connect all of these stars. But, for now at least, this is still a really big puzzle and a new star mystery that nobody can explain. The motion of stars in this case is actually quite chaotic and doesn't even seem to fit with the supernova explanation very well, and the stars seem to be moving all over the place as if they just formed and decided to go on their merry way. And this is very different from a typical dispersion, which usually takes a long time and usually involves just a few stars at a time. Here, instead of a gradual dispersion, this seems to have happened all at once. And though I guess a black hole might explain some of this, so basically maybe this was dispersed and destroyed by some kind of an intermediate mass black hole, here the overall chaotic motion doesn't really seem to match that either. The velocity of each of the stars seems to be kind of random and more than 20 kilometers per second, and does not contain any pattern. The only pattern that seems to be there is basically a kind of a correlation in terms of the actual spatial overdensity, or basically suggesting that initially these stars did come from the same location. And so exactly what happened in this particular case is very likely going to remain a mystery until we find something else somewhere else and can maybe make some links based on the observations with different telescopes. Additionally, as Gaia releases even more data, it might become possible to actually discover something else in this region that was previously missed. For now, this unusual Ophion star cluster, or Ophion star family, seems to be one of the strangest star associations discovered, well, really, ever. Right now it just does not make a lot of sense. And in this video we're going to discuss some of the new discoveries in regards to where our galaxy, the Milky Way, is headed. And I guess more specifically, we're going to discuss a relatively new study that identifies an enormous galactic structure that the Milky Way galaxy seems to be a part of, while at the same time explaining a little bit more about why our galaxy seems to be moving toward a mysterious point known as the Great Attractor, and also helping us visualize what all of this kind of looks like. But once again here we have to start with a bit of a history going back approximately 10 years. And so in 2014 there was actually a somewhat intriguing and somewhat groundbreaking discovery that our galaxy, the Milky Way, along with all of the nearby galaxies, and specifically all of the galactic clusters near us, seems to be a part of something much larger. By using some of the earlier catalogs observing various galaxies, and specifically observing their redshifts, back in 2014, researchers discovered that the Milky Way galaxy was a part of a region called Laniakea supercluster, with this image representing this supercluster and published by many different press releases at the time. The red dot, that's us, that's the Milky Way. Although in this particular image we're not actually looking at the structure itself, we're just looking at the motion of various galaxies, representing, as you can see, a kind of a galactic flow. A much better image is right here that actually shows us individual clusters and individual groups of galaxies, including the local group where all of us are located. But in essence, Laniakea represented approximately 100,000 different galaxies, all gravitationally connected and all moving in a certain direction. At least that was the discovery 10 years ago. But in some of the follow-up studies, including some of the more recent studies, researchers realized that it might be possible that Laniakea is not actually gravitationally bound, and something else might be in control, and specifically, it might actually disperse and eventually become something else entirely in the next few billions of years. Nevertheless, the discovery itself and the techniques used here essentially started a kind of a new search, an attempt to conduct additional surveys and to use additional simulations in order to discover a complex network of filaments, clusters, sheets, voids, and everything that's inside of them that essentially forms the mysterious cosmic web. the still mysterious, enormous structure that seems to stretch across the entire universe, and that seems to have been created as a result of initial quantum fluctuations during the early stages of the cosmic inflation. You can actually check out one of the previous videos in the description that talks a little bit more about how all of this works, but in essence, when the universe expanded, because of the quantum fluctuations, it formed these initial overdensities that then eventually formed the cosmic web. At least that's the current story, and right now there does seem to be quite a lot of evidence for all of this. But in order to understand exactly how this looks, and more importantly, how all of this affects our relatively tiny galaxy that's just traveling inside of this particular web, we obviously have to try to figure out what all of these enormous structures around us kind of look like. And that's basically what this new study was trying to accomplish. Here, by using nearly 40,000 groups of galaxies, with one of these groups basically being the local group, by using new observations from different recent surveys, scientists combined the redshift with the distance to various galaxies in order to essentially figure out where everything was moving once again, and in order to establish the overall density of everything around us. You can actually even see some of these locations that form this intricate cosmic web in this particular video. And so in this study, Dr. Vlad and his team essentially conducted one of the most complex simulations using a compilation known as Cosmic Flows 4 in order to help us visualize everything around us. And as you can see, the images and the videos look absolutely incredible. The Milky Way, by the way, is right in the center. And well, here, one of the primary discoveries was once again that Luniakea might not actually be our superstructure after all. Or to be more specific, it's actually just a part of a much larger structure, all connected into something absolutely ridiculously massive. In other words, Luniakea in this case is just one of the smaller limbs. And so by using details of millions of different galaxies around us, one of the first discoveries was that Luniakea, and obviously the Milky Way galaxy, were actually all moving in a certain direction. In other words, there was another what's known as a basin of attraction, BOA for short. And we know that the Milky Way galaxy, and actually all of the galaxies around us, are moving toward it. The only problem is that it's actually located behind the galactic bulge, so it's extremely difficult to figure out what's there. Because all of this dust is blocking the view, this region is extremely difficult to study. Scientists refer to this as ZOA, Zone of Avoidance. But inside of this Zone of Avoidance, we've always known about this one particular region referred to as the Great Attractor. You can actually learn about this in some of the videos in the description, but in essence, it's a point where everything around us seems to be moving toward. A mysterious point that potentially produces a lot of gravitational pull, or, much more likely, a location along the cosmic web where a lot of galaxies around us seems to be flowing toward. Or essentially it's a kind of a downstream inside one of the networks of the cosmic web. But in this new study, scientists discovered something else that's even more intriguing. Turns out that even the Great Attractor and everything around the Great Attractor seems to be moving toward the same location as well. In other words, the flow does not stop at the Great Attractor, it just keeps going. And so all of the structures you see right here, including the humongous Luniakea, along with all of the additional groups, seem to be kind of attracted towards something else. And so intriguingly, Luniakea and all of the galaxies in it seem to be actually headed toward what's known as Shapley supercluster. And specifically the location scientists now call Shapley BOA, Shapley Basin of Attraction. And Shapley supercluster has been known to us for a very long time. It's essentially the largest concentration of galaxies in the nearby universe that seems to be at least 650 million light-years across. But because Shapley supercluster appears to be moving in the same direction as Luniakea, and they all appear to be moving toward the same point, this basically suggests that all of the galaxies inside Luniakea, including the point known as the Great Attractor, seem to be moving toward Shapley supercluster and some kind of a point inside of it. Now I guess we can call it a Shapley Great Attractor. Which basically means that Luniakea is just a much smaller part of the much larger cluster, or just to rephrase this, the Milky Way is part of the Shapley supercluster as well, which in total encompasses over 700 million light-years of galactic space, and thus form one of the largest structures out there, but not the largest. As a matter of fact, one of the additional discoveries in the study is essentially other superstructures and their overall map. And amongst these newly identified regions, one of them really stood out. The so-called Sloan Great Wall. It seems to be the largest basin of attraction currently known to us, and as you can see from this simulation, is definitely much larger than Shapley and Laniakea together. But here you can actually see some of the other structures as well, which in essence creates this beautiful three-dimensional map of enormous superstructures traveling in outer space, following the mysterious cosmic web, making this a really impressive achievement and a really beautiful image. And because here we're talking about space billions of light years across, it's obviously somewhat difficult to put this in a perspective, because here we can't even see the Milky Way galaxy. Forget about seeing planet Earth. But importantly, this new study provides us with a completely new look into the gravitational landscape of the nearby space, showing us how various galaxies and cosmic structures evolved over time and very likely will continuously evolve for billions of years. It also kind of reshapes our understanding of the cosmic flow just a little bit, while also revealing extremely massive structures we've never really imagined, and the enormous influences they have on galaxies around us, just because of the sheer amount of mass involved. Although in this case, once again, this only focuses on the overall motion of galaxies. In other words, what you're seeing right here is a structure formed through densities of galaxies as they move across outer space. As a matter of fact, the galaxies on the outskirts here, technically, because of the expansion of the universe, are moving away from us at 30,000 kilometers per second. But in this particular simulation, it's very difficult to imagine any of this, and so even grasping at what we're actually looking at here is a bit challenging. But it definitely looks really cool and somewhat artistic. I mean, this is real art, the art of the universe. Although when it comes to understanding the actual map of the universe, I think this here presents us with the best visual representation. Here this shows us the distribution of these basins of attraction and various loosely connected superstructures that hundreds of thousands of galaxies seem to form as they travel in the cosmic web. But because all of this also shows us how the universe will most likely evolve over time and how many of these structures will change as well, I'm sure in some of the future studies, researchers might even be able to predict where all of this is going to end up in the next few billions of years, eventually helping us answer questions about the eventual fate of the universe and of course the fate of our galaxy as well. But it's also important to remember that this only represents a part of the universe, roughly around 1 billion light years away from planet Earth. And since the observable universe is much larger, with time this picture will probably expand as well. In other words, the distance from the Milky Way to the edge observed here only represents like 2% of the observable universe. And so these are the largest nearby structures, but not the largest structures in the entire universe. In the last couple of years, several major studies started to report discoveries of somewhat unusual cosmological signals. Strange blinking objects scattered across the Milky Way that were not very easy to explain. And they were actually discovered completely by accident because of the advances in radio astronomy. Now in the past, many different blinking radio objects have been discovered as well, but these were usually extremely fast, and today we refer to them as pulsars, essentially pulsating neutron stars, whose spinning mechanism seems to produce these very specific radio emissions. But here this was something entirely different. The first such object was only discovered in 2022, and this was like nothing we've seen before. Here, in some sense, this was also a pulsar, but it was basically in slow motion. At 4,000 light years away from us, this unusual signal was actually producing 30 to 60 seconds of radio emissions every 18 minutes. And it was reported in this study by Hurley Walker and the team you see right here. You can also learn more about this in one of the previous videos in the description. And though even back then there was barely any explanation, it didn't take long to discover the second object, 15,000 light years away, emitting radio signals lasting for 5 minutes with a pulsation of 22 minutes. This was discovered by the same researcher and the team you see here just a few months later. And while eventually Natasha Hurley Walker that you see right here continued to discover more and more. For example, here's another one discovered just 1 year later, 5,000 light years away, 30 to 60 seconds long, every 2.9 hours, with at least 10 such objects now known as of 2025. And though it's still unclear exactly what these are now known as LPTs, long period transients. So I guess kind of like pulsars, but just super slow. But even after all this time, there is really still no exact explanation. Because these are completely new to us, nobody has any idea what's going on and how these signals are generated. Nothing like this has ever been seen before, nothing like this has ever been predicted, and these radio signals are just way too slow to be neutron stars or magnetars, and way too powerful to be anything else. Also, they look just a little bit too natural and too unpredictable to be aliens. And so basically here we're stuck with these new, strange radio mysteries across the entire galaxy. They seem to resemble pulsars, but pulsars with signals at least 1,000 times longer. And because of the way we know pulsars generate these signals, it would be impossible for them to spin so slow. Here we're talking about rotation in hours or even in days. Not to mention that these are really strong signals, suggesting that whatever this is, it has to be super powerful. But so far the majority of these discoveries basically came from this telescope. This is known as ASCAP, Australian Square Kilometre Array Pathfinder, which in the last few years produced some of the most incredible radio maps of the entire night skies. We've actually discussed a couple of them in some of the videos in the description, and one of them still kind of blows my mind. It's literally this three-dimensional interactive map you see right here, where you basically see a bunch of objects, but all of them only visible in radio light. And here you can actually click on individual objects to see exactly what they look like as a radio emission compared to what we're usually used to. There's a few other maps we've discussed before in some of the videos in the description, but in essence, because of these discoveries and because of these new maps, or technically because of these new surveys, there was now a lot of new data that was previously unavailable, including data on various pulsating objects that were actually pulsating relatively slow. And this is how some of these LPTs were discovered initially. But now we have a new discovery that completely by accident became even more exciting. Here this is an object 15,000 light years away that you can kind of see right here. ASCAP J1832-0911. It seems to emit 2-minute pulses every 44 minutes, which essentially makes it another one of these LPTs. But when ASCAP was collecting data about this object, completely by accident, it was also observed by Chandra. And as you might know, Chandra Space Telescope can only see things in the X-rays. And here, it also recorded very unusual pulsations that seem to correlate directly with radio signals. You can see both radio signals and the X-rays in this image. And to astronomers, this is a really strange behavior. These somewhat methodic radio signals, with every pulse produced with such an unusual regularity, and visible in both radio light and X-rays, is actually even more difficult to explain. Especially because the pulses coming from this object are extremely bright, producing a lot of luminosity in the X-rays and in radio waves. But on top of this, based on these observations and further analysis, researchers established that this has to be a somewhat compact object, basically relatively small in size, and it seemed to produce no emissions before November 2023. So it actually only became this way extremely recently. Like here we're just talking about under 2 years. And that's super bizarre. For example, every single pulsar known to us has been active and has been pulsating for as long as we've known them. And they are expected to pulsate for many years. Normally, for a typical pulsar to stop producing radio signals, it has to slow down its spin just enough for the magnetic mechanism to no longer produce enough radiation. And normally it's expected to happen maybe within 10, but usually 100 million years. And also they're unlikely to just start like this out of nowhere. Yet here, this object defies all modern theories. And as always, you can read more about this in the study right here. Detection of X-ray emission from a bright, long-period radio transient. A study by Zita and Wang and the team you see here. And based on previous models and previous explanations, right now not a lot of them actually match. For example, before it was proposed that maybe these are extremely magnetized neutron stars, or maybe white dwarf pulsars, or possibly even binary systems with a white dwarf and some kind of other star that seem to produce these emissions because of very slow spin or because something is orbiting around them. But these particular models did not predict X-rays. And though X-ray emissions could be possible from ultra-long period magnetars or some unique white dwarf pulsars as described in this study, none of them produce radio signals and X-rays in such an unusual synchronized way, and none of them have these very long, very powerful emissions. And so right now there's really no clear idea exactly what's happening. For example, here you're seeing one of the previous explanations that involved some kind of a pulsar striking a star that then produces emissions from its surface Well, we also observe emissions coming from the pulsar as well. But even these theories do not fully explain what we're actually seeing. And so right now the assumption is that this is an entirely new type of physics when it comes to stellar evolution and stellar objects. Especially because even though the radio and X-ray pulses seem to resemble a magnetar, the overall behavior and the emissions are not consistent enough with magnetar activity. Or just to rephrase this, the radio and X-ray emissions look nothing like what we usually see from a typical magnetar. And if this is a white dwarf, and a white dwarf that's spinning super slow, it actually seems to be several million times more powerful than any other white dwarf seen before. Not to mention that usually white dwarf emissions are also polarized. Here the radio light is very different. And so right now one of the potential best next steps is to try to observe previously detected LPTs and try to see if they also emit something in the X-rays and maybe some other wavelengths. If scientists discover that all LPTs produce X-rays and radio emissions, this might definitely point at some kind of a new stellar object and some physics we've never really considered before. Or maybe this is just a very unique object and something very different, never before seen in the entire galaxy. In this particular case right now, this is a very energetic object, producing just as much energy as a typical super flare from a very active star. In other words, every single one of these emissions is just as strong as an extremely powerful flare coming from some of the most active stars out there. But because it's only started recently, and because in the last 6 months the X-rays and the radio emissions seem to have actually died down a little bit, seems to suggest that whatever this is, it's not going to be permanent, and it seems to be only affecting this object on human timescales. So for all we know, in the next few years, it might disappear completely. And that means that we might not have enough time and not have enough observations to determine what this is. What is certain though, this is definitely like nothing we've seen before, and right now seems to be one of the most unique objects in the entire galaxy, and technically the entire universe. A strange radio and X-ray pulsator producing signals every 44 minutes. Something we'll discuss again once there are more discoveries or more clarifications, or once someone proposes something concrete that explains all of these bizarre pulsators once and for all. But until then, that's all I wanted to mention. Check out some of the previous videos in the description. Thank you for watching, subscribe, come back tomorrow to learn something else, support this channel on Patreon where you can actually find quite a few additional videos, and obviously no ads. Maybe support this channel by joining the channel membership by buying the Wonderful Person t-shirt you can find in the description. And either way, stay wonderful, I'll see you tomorrow, and as always, bye bye.